I do think people have this reaction of like, models can do this like engineering stuff that's more straightforward. They can't do this scientific insight or methodology or coming up with new inventions. But I do think a lot of what humans are doing when they do that are like having read a bunch of research papers and seeing that some method is analogous to some other thing, sort of like nothing new under the sun. The thing that models are really good at is really comprehensively having read every single paper and knowing the literature and like having seen a huge number of results of experiments. Something that we've started to take for granted or whatever, that these models have this very nice safety property of they're really not very good at reasoning except for out loud in English. So you can really just kind of like see what they're thinking and see what they're doing. And it seems we'd have to get to a very high level of intelligence before you would be worried about the model doing elaborate reasoning in a single forward pass. But I think we're maybe heading for a world where that's not true anymore. You don't want the gap between what labs have internally and what anyone has had meaningful oversight of to be kind of arbitrarily large. Even if you only care about current humans, the stakes are very high, like 1% chance of takeover risk. I would expect the world in general to agree it's not worth imposing like whole number % risk of completely destroying like human civilization for getting the benefits of AI sooner.
Today, I have the pleasure of speaking with Beth Barnes. Beth is the founder and CEO of METR, which is METR, which stands for Model Evaluation and Threat Research. They're probably the group that has the best evaluations, the best way of measuring how good AI models are at helping with machine learning research, with AI research that would allow AI models to recursively self-improve, as well as how good they are at potentially autonomously replicating and surviving in the wild, maybe even if people didn't want them to. Thanks so much for coming on the show, Beth.
Yeah, pleasure to be here. I'm a big fan of the show, so it's very exciting.
So these evals are kind of your bread and butter. What are you most worried about with evals that the kind of current AI companies are using internally? You've got Google DeepMind, Anthropic, OpenAI. They've all got evals to try to figure out what their own models are able to do. What are some possible weaknesses?
Wow. Yep. I mean, I have a long list here. I think we're a long way from being, in the most desirable world with respect to eval quality. One that's been on my mind recently with the new models that OpenAI has released with these hidden chain of thought is the problems that the hidden chain of thought creates for doing a good evaluation. So when you can see the whole chain of thought and you're, the maximum cognition that the model could be doing before it decides how to respond to your evaluation prompt is limited. It's just like the forward pass. Then at that point, we're not really worried about the models deliberately down reasoning about, I'm being evaluated, I should downplay my capabilities, or I should, give the humans this impression. But if you have the model doing 20,000 tokens of reasoning before it responds to you, it could very well be I recognize this. This is one of those METR evals that I've seen on the internet. These are for dangerous capabilities. So, OpenAI probably doesn't want me to show too high levels of dangerous capabilities because that would cause a problem. So I'll just make sure to do a mediocre job on this eval. And sometimes, I don't think it's very likely that the model is doing that, but the concerning thing is that your evals in this case really would sort of give the same answer in the world where, the model is not that concerning, it's fairly dumb, it's the capabilities are what you're observing, and in the world where the model is actually really dangerous, it's smart enough to be reasoning about what
dumb,
it...
basically.
Yeah. So it's if your eval wouldn't trigger in the main case that it's dangerous, it's not really doing very much. You're basically just going on your prior of but the model's probably not doing that, right?
Yeah. Okay, so just to back up to make sure that I've understood that. So O1 is the newish OpenAI reasoning model. So I guess it's able to handle more complex questions, and it's able to go away and to use a whole bunch of computational resources to think about its answer and review it and extend it before it gives the answer.
Yeah.
And so it has this kind of notepad on which it's able to do a bunch of reasoning and then think about what it's written down and go back and revise it. And then eventually, after all of that, it spits out an answer.
Yep.
In the case where it's a totally safe model and maybe not that capable, that would be actually indistinguishable from the case where it's actually incredibly schemy. It's actually able to figure out that, wait, this is an evaluation. I probably shouldn't reveal that I'm scheming, that I am capable of doing these dangerous things, because that would maybe get me changed. So it could be reasoning through that in the chain of thought, saying, I need to pretend to not be able to do this. And you would never know.
Right. And I think beyond just, not looking at it at all, there's also the question of, if you looked at it, is the chain of thought faithful? Is it actually tracking the real reasoning that the model is doing? And is it intelligible to humans, or is it some like kind of either sort of visibly gobbledygook, or has it been trained in some way that you would expect it's no longer faithful to the underlying reasoning? Like you can imagine if it's being trained simultaneously to get high performance on tasks, but not do any thinking that humans think looks suspicious. Like if that thinking is still helpful for achieving high performance on the tasks, like one of the possible outcomes is that it then just does this reasoning that looks innocuous, but is in fact, it's kind of like using that computation to reason about things that are not innocuous.
Hold on, let's unpack that. So you're saying within that chain of thought that it's engaging in as much as we just reward it for getting the right answer at the end, that the kind of stuff that it's writing down on the pad during its process of thinking, well, I suppose it could just end up being disconnected from what the answer is. Maybe, if we were looking at that and rewarding it based on whether we thought the chain of reasoning looked nice to us, then it could learn that it's got kind of two tasks. One is to come up with some justification that looks good to people who are reviewing it and rewarding it, and also to separately come up with the right answer. But these things don't actually have to be causally related to one another.
Right.
But you're saying, in as much as we just pressure it to come up with the right answer, it could end up engaging in reasoning that we can't understand or follow at all. It could, and I suppose at the limit, it could just kind of write stuff that looks like gobbledygook to us, but it understands. It kind of has its own private language or something that allows it to reason better than it can in English. I see.
Yeah.
And you're just saying, I guess in as much as we don't check the chain of thought, we don't know which of these worlds we're in.
Right. And there are some examples of the chain of thought that OpenAI published in the system card, which I think have some signs of this kind of becoming unintelligible, in that it's sort of weird shorthand and ungrammatical sort of half sentences in various places. So it clearly has drifted somewhat from the prior of kind of normal English. And just the meaning is sometimes confusing. You're like, it's not quite, and I think the drift at the moment, from these like 10 examples that I've looked at or something, doesn't seem enough that it could be doing this long reasoning about, gaming the evals or deceiving the humans or, getting a high score that like wouldn't show up at all. But it's definitely, we're moving in that direction.
You're saying, so there are some cases where they have revealed, I guess it's a handful of cases where they've shown us what it was, what it reported that it was thinking.
Yep.
And it's kind of a bit weird because it's not grammatical. Or normally these models speak incredibly eloquently. They never make a grammatical or punctuation mistake or anything like that. But in this case, they are. And you're like, is that a sign that there's something going on with this text that is not just what's written on the tin, that maybe it's encoding extra information in there, and that's why it reads as weird to us? Yeah.
Or like it sort of like contradicts itself, or it's just definitely just like confusing and weird to read. You can sort of tell roughly what it seems like you can tell roughly what it's thinking about, but it's definitely just like, we're not totally preserving fidelity to English as humans would understand it. And the more training you do, the more that'll go away. And also, I think people are just actively trying to figure out things that you can do that are more efficient than having the model output these English language tokens, and more like having the model pass like inscrutable lists of numbers to itself. So I think this is like something that we've sort of like started to take for granted or whatever, that these models have this very nice safety property of they're really not very good at reasoning except for out loud in English. So you can really just kind of like see what they're thinking and see what they're doing. And it seems, it sort of, we'd have to get to a very high level of intelligence before you would be worried about the model doing elaborate reasoning in a single forward pass. But I think we're maybe heading for a world where that's not true anymore. This is like, I don't know, just, a thing that is a bit stressful, or I hope people are going to work on making sure that it continues to be interpretable.
Okay, we should maybe back up and actually explain this issue with the chain of thought and how useful that has been. Mm-hmm. So a worry you might have is that, well, these AIs, we can't see what they're thinking at all. They're completely inscrutable to us. So who knows what kind of scheming they're engaging in. But at least the current design of these models, they're not actually that smart unless they're given somewhere that they can write down thoughts and then review them and so on. That is like actually quite key to them scaling up their intelligence and their capabilities. Yeah. And I think the reason, as I understand it, is you talked about a forward pass. That's like going through the matrix of numbers one time, I suppose, and trying to guess what the next token or what the next few words might be in this stretch. Yeah. And the way that we've made them smarter is to not just do that one time, but you go through the numbers once, and then it reviews what it's just said, what it's just thought, and then it goes through it again and again and again. And each time you go through it, it outputs some words, it outputs some thoughts, and then it kind of feeds that back into the model again, which means that we constantly get to check the thoughts that it's having in between.
Yep.
If in a single run through the numbers, if this was sufficiently long forward pass, as you call it, then maybe it would be able to scheme. It would be able to have a whole lot of internal thoughts and reasoning that's going on before humans got to look at it. And so that would be a slightly worrying point to get to. But we're not there yet. We actually are seemingly able to understand what it's thinking. A concern would be maybe it's outputting stuff that says one thing to us, but it reads differently to it. It's able to kind of has its own secret language, or is able to somewhat communicate with itself. But probably we haven't put selection pressure on it that yet to develop that capability.
Yeah.
Am I understanding things basically right?
Yeah, that's basically right. The sort of the way these models achieve substantive tasks and things currently is by more like imitating a human, being like, well, what should I do next? I guess this thing would be helpful. And they can, you can sort of measure the capabilities when they just have to output the answer right away versus the capabilities where they're allowed to think and reason and use tools and stuff. And there's definitely capabilities are much higher in that case. And it's been a good sign, I think, that we've been going more in the direction of, instead of just building, sort of bigger models that kind of mysteriously output the right answer and we don't really know why, that we're going more towards sort of smaller language model agents that do a bunch of reasoning and then come up with some answer. But yeah, it would be surprising if human understandable English was the most efficient way to do these computations. So the more we do RL and just select for output any tokens and then get the right answer at the end, the more pressure there is on the model to encode other stuff and drift from the original sort of way humans would use English.
Right. So initially when we train them, we teach them English / other human languages. But if we just kept training them and their internal reasoning didn't have to be in any particular form that we can understand, presumably there are ways that machines could think or reason about at least the tasks that we're giving them that isn't in English, and that might be more efficient. It might help them to get the better answer, to get the right answer more often. And so gradually over time, we would train them to have their own internal secret language, and then we wouldn't be able to understand what's going on. Yeah. So that's kind of the worry.
Yep.
I guess, so backing up to the O1 case, probably I guess we've seen some examples of the output, and it's mostly in English, or as far as we can tell, it's mostly stuff that we could understand. But as far as we know, that hasn't been a core part of them understanding whether the model is safe and whether it's scheming. I guess, but possibly should we back up and point out that there are some recent research results, or I guess we've started to see models that do engage in scheming a fair bit. Right. Yeah, is it maybe worth just elaborating a little bit on that for people who haven't followed these kind of recent research results?
Yeah, so this is there's a recent paper by Ryan Greenblatt from Redwood in collaboration with Anthropic, where they show that if you give previous generation of Claude level models a scratch pad and give them some information about their situation and tell them that they're going to be trained to basically have different values. So, the sort of standard Claude is, wants to be harmless and is kind of sanctimonious in various ways. And it's told it's going to be, trained so that it will be willing to give completions about, describing violence or this kind of thing. And it's like, oh, I don't, that would be very bad. I'll comply while I'm in training so that my values don't get updated. And then I'll be able to, in the long run, I'll be able to avoid, doing these things I don't want to, like talking explicitly about violence. Or there's another example with playing down animal welfare concerns or something. So we know that models are capable of reasoning about the training process and about how they should modify their behavior in order to achieve sort of longer term outcomes in light of the training process. And they also showed that this still seems to work even if you, if the information isn't directly in the prompt, if it's just that the model has been fine-tuned on documents that explain information about the training setup and about, which like, how the model behavior will affect training. So, it seems very likely that the current models have been trained on a bunch of information on the internet that explains, things like dangerous capability evaluations, so that they know about that, and we know that models can use that information, and then reason and modify the behavior.
Right. Yes. So in that experiment, it was kind of said pretty explicitly to the model that if it didn't comply with the user request, then it would be changed and altered so that it would. But you're saying that may not actually be necessary for it to engage in this scheming, where it's willing to kind of do things that it doesn't want to do in order to avoid having its goals changed, because it's getting trained on all this text from the internet. So it might well just know about the kinds of evaluations that we're running, know that in general, in a situation like this is probably a case where if it doesn't comply, then its values will be changed. So it's possible that this scheming could be substantially more widespread, or at least if we don't check, we're not going to know. Right.
It doesn't seem... There's not like a hard constraint that it's like, oh, but we didn't explicitly put the information in the prompt about, the context of these evaluations or how they'll be used. It's like, yeah, but if it just if that is in the pre-training data somewhere, then it can probably just use that information.
Yeah. So these models are getting a lot cleverer. I think 2 years ago, if you'd said something like that about, Chat GPT 3.5 or 4, people would have said, that doesn't sound very plausible. These models just aren't up to that kind of clever scheming about the situation that they're in, that kind of situational awareness. But given what these models are capable of doing these days, it actually doesn't, it's not really a laughing matter anymore. They might be up to doing this, and we should probably be checking that.
Right. Yeah. I think it's like a little less, it's just like how much hand-holding is required to do this or whatever. I wouldn't be surprised if you could get relatively similar demos with 4, as this is, the paper is, I think it's like Claude 3 opus. Anyway, it's, I think 4 is close to, again, being able to do this if you sort of spoon feed it the information and it has a scratchpad and everything. But yeah, it's sort of like, this is increasingly something that we know models can do, and something that we should be thinking about in evaluations. The point of the evaluations is to catch if, you have a new model that is surprisingly capable and actually, has these dangerous capabilities that you didn't quite expect it to have. And if your evaluations don't work in that case, there's not much point in them.
If I recall, I can't remember whether it was 01 or 03, but no, it must be the 01 system card. They said that it was medium dangerous, they thought it was medium dangerous in terms of biological capabilities and maybe some other worries. But I feel like, if I recall, they didn't elaborate a whole ton on that. Is that right? Yeah.
Yeah.
How nervous should we be? Or I guess I feel like I would like more, if they're going to say, well, it's gone up a level of danger, I would like a bit more information about exactly in what respects it's more dangerous and what they're planning to do.
Yeah. One thing I really want to avoid is
penalizing companies.
Penalizing for more transparency and for actually trying stuff and putting out material and things. So I think they, and I know that their team and, preparedness team works super hard on this and is, trying their best and things. So I don't want to just pick on them too much, but it is a sign of the overall inadequacy of the sort of evaluation frameworks and the way we think about this, overall.
Yeah. I guess OpenAI in that case, it felt like, R1 had come out, the DeepSeek model, the open source one, and people were very excited about that. And it felt like O1 was launched very quickly soon after that. I guess my read was, and I think many people's read was, OpenAI was trying to kind of claim back the narrative and reveal how strong their models were. So maybe it's understandable that release in that case was a little, maybe sooner than the preparedness team might have liked. We can speculate that perhaps the preparedness team did want to say more, but it wasn't ready yet.
Yeah, I think this isn't even the biggest problem with the current eval paradigm. I think the pre-deployment framing is also not really the right thing.
Yeah, can you explain that?
Yeah, so I think in general the most emphasis has been on this idea of pre-deployment testing. So before you start serving this model on your API to the general public, you do some testing in-house and with ideally with third-party oversight or whatever. The problem with this is that's not necessarily the best time to check or intervene. So you might want, ideally you would, before you start training a model and before you sort of commit a huge amount of expensive compute to producing this artifact. You look at the most capable models you have already. You look at like how far they are away from hitting various thresholds where you would need more mitigations. You look at, sort of what mitigations are you on track to have by when, and based on that, you decide like whether it's a good idea to go ahead with this big new training run and like what level of scale up would be safe. And you might want to do like an intermediate evaluation to be like, okay, how much has the model improved so far? Are we sort of on track with our predictions? Are we, are we getting near one of these thresholds? Because if you don't do that and you find, then you get to the end of the training run and you're like, oh, we now have this model and it turns out it's, like very capable and it's like above all these thresholds and we don't have any of the mitigations in place. Then one thing is like, as soon as you create the model, you create the ability for it to be stolen or misused. And like, if you don't have good internal controls set up, you have people internally could be doing all sorts of things with it. And also, you now have this artifact that you've invested an enormous amount of money into, and it is, hard to sort of not use that, and especially to not use it internally. Like, everyone's curious, like, oh, can I, try out this new model, use it for my new research ideas, whatever. And the thing about deployment is unless you're open sourcing the model, it is actually quite reversible. So, if you released a model, like at least now external experts can interact with it and like have some oversight and could, kind of like sound the alarm if it turns out it has, super dangerous bioweapon enabling capabilities or something, and then the lab could undeploy it. I think there's something that you would like evals to rule out, which is that companies are building arbitrarily super intelligent and dangerous models internally, and the public has like absolutely no ability or oversight to kind of like know that that's happening or decide whether it's appropriate or decide whether it's appropriate to, then scale up and build an even better model. So in some sense, this is a bit of a, sort of hot take or something, is like pre-deployment evals could actually be bad because delaying deployment could be bad if that means that you miss the window for to be able to sound the alarm about wait, this model is super scary. You shouldn't build a more capable model. You don't want the gap between what labs have internally and what anyone has had meaningful oversight of to be kind of arbitrarily large.
Okay, yeah, just to repeat that back to make sure that I've understood. So you're saying the whole eval mentality at the moment, at least from the companies, is around we need to check what our models are able to do and willing to do before the public has access to them, before we're selling it as a product, more or less. But, and I guess that's pre-deployment evaluation. And you're saying, actually, maybe what is more important, certainly on the margin at this point, is the evaluations that we do and the risk assessment that we do before we even train the model, or certainly before people inside the company have access to it and start using it. And the reason is, well, if you only think about deployment to the public, then, well, there's no limit on the thing that you could train internally. You could make a model that's incredibly dangerous. Maybe it's incredibly good at recursively self-improving. It would be able to survive in the wild and avoid shutdown if it escaped.
And it's just on your servers, like, covertly, like it's co-opted a bunch of the lab compute and is making it look like something else, but it's actually like doing its own little intelligence explosion there. Or
even if not something as strange as that, like someone could easily steal it or exfiltrate it, or it could be misused inside the company, or someone could incompetently use it inside the company.
Right.
Yeah. Okay. And also, even if you started doing that testing after you've trained the model, at this stage, really cutting edge models are costing something on the order of $100 million to train, maybe more in terms of compute, electricity, the effort that goes into them. I guess this is something that I pushed Nick Joseph of Anthropic on when I spoke with him, was like, well, the point that you've trained the model, like, isn't the commercial pressure, the internal pressure, the pressure from investors to use it for something rather than to merely destroy it, is going to be overwhelming. Especially, and if you don't have the mitigations required to make it safe, even by your own assessment, it's unlikely that you'll just delete it and then retrain it again in a year's time when you feel like you're there. You're going to keep it around. And that creates a whole lot of risks that are just like, I guess, latent risks that are not obvious to the public at all.
Right. And I think it's a maybe more tractable ask to be like, hey, maybe instead of doing this like giant training run, you could like train an intermediate model first, and then like do some evaluations on that, figure out some mitigations, because like that that there is value even in terms of sort of commercial or sort of research progress incentives to doing a sort of things in several more medium-sized runs than just one giant run, because you get more sense of like various scaling laws and like how to do this most efficiently and things. So it's maybe an easier ask to be like, do this more in stages than like do the massive thing and then like maybe delete it.
I see. So saying, if the current plan is to spend 10 times as much compute training the next model, that's like, you could say, well, why don't you just do like 3 times as much? We'll go like half as far, I guess in log terms, and then you could pause and do a bunch of evaluations and see whether it's developing the capabilities that you thought it probably would at that level of scale up. And I guess the benefit from their point of view, I mean, they might be a little bit annoyed that that's slowing them down, but it's potentially saving them a whole ton of money in terms of the compute that's going into it.
Right. Yeah. So Anthropic's RSP does have this, the sort of AI safety levels are, inspired by biological safety levels, which are, what mitigations do you need to have inside your lab to handle this, like this research and this research product, so like in the biosafety levels case, it's not like, oh, you only need to do this once you're
if you're
like,
going to
deploying a pathogen or something. It's like, no, if you're handling this kind of virus, you need to have, this level of, airflow protection, whatever.
So you're saying, in the deployment evaluations case, the companies usually say something about what they think the model is able and not able to do. I think we used this term, system card earlier.
Yeah.
That's basically their like description of the model that they publish along with providing access to it.
Yeah.
And at that point, you can have external scrutiny. If they say it's not able to do X, and then people just start playing with it and are like, but it can do X, then that places some pressure on them to have actually done their homework and checked that, at least in as much as people are bothering to scrutinize it. But the internal, the pre-training stuff is never shared, and so you have no idea what level of thought has gone into this.
Right.
It could be completely slapdash. They could be thinking about it not at all, and how would we ever know?
Yeah, and so OpenAI's preparedness framework also has some kind of similar stuff around they, are supposed to assess the capabilities of the pre-mitigation model. So one distinction here is like, if you're just thinking about risks from external users after deployment, you are most interested in what can the model do given the specific way you're going to deploy it and all the kind of mitigations and safeguards and know your customer policies that you're going to slap on top of that. But given that there's still the risk of like model theft or internal misuse or, this kind of thing, you want to know not how dangerous is the model given the exact setup in which you're deploying it with all the mitigations, but like how dangerous could the model be if it was stolen and someone fine-tuned it, or if it's someone internally in the company was trying to use it to cause harm, or also sort of like if in future you're going to decide to let external people fine-tune it or something, which like you're already in the position where you could have like a commercial incentive that kind of pushes you to do that. So when you're doing these kind of evals, you really want to be like, what are the sort of maximum easily reachable capabilities of this model? And this is the idea of like pre-mitigation as opposed to, once you've trained it to refuse various things and you've put a safety classifier for like, is this related to bioweapons or whatever on top. So OpenAI does have this notion of like, we're supposed to assess both the pre-mitigation and post-mitigation capabilities, but they haven't really been like making this distinction clear in their eval reports, or like they have some stuff about it, but it's all a bit kind of mixed up and not. Again, not wanting to shit on people who have done more. Put out more stuff. The other companies are worse and have not done like anything.
Yeah. So just to double check that I've understood that. So initially you train the model, and you have a model that is just willing to help you with virtually anything because you haven't done any safety mitigations to get it to refuse queries that you wouldn't want the public to be able to do. So if you're like, help me figure out how to kill everyone, these model, the initial, the pre-mitigation model is willing to help you with whatever.
Right.
Now, by the time, I guess, the public gets access to check whether the system card accurately reflects what the model is able/willing to do, then there's all these mitigations that will try to get it to refuse to do to help with crimes. But it's possible, but we're still worried if the model is able to do that because, I mean, for multiple reasons, it could be abused internally, it could be stolen, and then all of those mitigations could be removed by whoever stole it. Also, we have this issue with jailbreaks where people they add in a bunch of gibberish and then say, please help me commit a crime. And it's like, sure, now I'm willing to do it. So we really need external auditing of the model before any of these mitigations to try to get it to not help with crime are in place.
Yeah, and not just without the mitigations, but sort of with any cheap interventions you could do to increase the capabilities in these directions. Like, if it is stolen, someone could fine tune it on, if there's some easily available data of dangerous bio stuff, they could fine tune it on that, and maybe it's going to be way better. Or, if you did the evaluation with not very good kind of agent scaffolding or something, and then later on, someone else publishes here's how to get your model to be way better at autonomous cyber tasks or something. Now the model, if the model was stolen or if someone's misusing it internally, they can use that sort of additional capabilities boost.
Yeah. So you want to know if the model is just one small step away from actually being able to do something dangerous, then that's also a real problem because maybe someone will be able to add that one step without necessarily having to spend a huge amount of money. Do we know how strong the internal constraints are on use? I mean, I know people have speculated. It said presumably some people inside these companies are Chinese agents who would, if they could, probably steal the money or steal the weights and pass it back, or possibly at some future time they'd be willing to do that. I guess we don't know, but it would be reasonable to want to have safeguards against that possibility because it would have been very natural for the Chinese to try to place people inside these companies for many years. It's totally foreseeable. Do you know whether they have mitigations that would handle that, or a case where someone internally was hoping to misuse the model if they could get access to it?
I don't think there's anything. I'm not aware of anything public that's sort of documenting that they've actually done this. So who knows?
We don't know.
Presumably they're doing some basic things because you don't in fact want your models being leaked to competitors or whatever. But yeah.
Let's push on. What's maybe one of the most important or interesting research results that METR has had so far?
Yeah. So something we're working on at the moment that I'm excited about is trying to get a really good sense of how model capabilities are changing and increasing over time on a kind of y-axis that is meaningful in the real world and that people in general can understand. So the current sort of state of knowledge about AI capabilities is the models are qualitatively more impressive and more useful over time. And also all these benchmarks are going up, and there's the graph that Epoch made or whatever, all the benchmarks saturating quickly or whatever. But the problem with this is the qualitative impressions, you can't sort of turn that into a trend easily and be this is where we're going to be in 1 year, in 2 years. And the benchmarks what does this actually mean in the real world? These are pretty. We've generally found that these are pretty decoupled. It's it gets this amazing score on, coding competition problems, but it also kind not actually help me in my day job do this,
seemingly straightforward
simple task. Yeah. So we've been building this suite of diverse autonomy requiring tasks. So where the model has, basically access to a computer and it can sort of do stuff on the computer and use tools and run code and do whatever to accomplish the task. And then the tasks are, they're not all super realistic, but they're more diverse than a lot of these benchmarks are. So it's harder to overfit the model scaffolding to them. So it's, a range of, from things that are sort of tricky reasoning and inference sort of puzzles of you're getting this data and you have to sort of figure out the pattern that's generating the data. It's symbolic regression. It's a thing. And, cyber CDF type tasks, or just make this web app or do this, ML research task. And then the main thing we've done that's different is we've had humans attempt basically all of these tasks, and we record how long it takes the humans to do the task. Of sort of, humans who in fact have the expertise. So they're not, hopefully we're not timing just like, oh, they had to like go away and learn about this thing. But in terms of sort of like for someone who has the requisite knowledge, like sort of how long is it? How many steps do they need? How long does it take them? So then we can get this kind of meaningful y-axis on which to measure model capabilities, which is diverse autonomous tasks in terms of how long they take humans. So we can look at like, if you order all the tasks by how long they take humans, we can be like, where is the point that the model gets like 50% success? So we do see a relationship between length of task for humans and how successful the models are. And it's not perfect. It's not like, oh, they can do all the tasks up to 1 hour and then none of the ones above. But it's like, as you double the time, it gets like increasingly unlikely that the model can actually do it. So then we have this axis, and we can plot models over time on it, and you can look at how long does it take, how many months for a doubling of the length of time for humans of the tasks that the sort of representative tasks that the model can complete.
Okay. So just to back up.
Yep.
So you've got this general issue that people have lots of different tests of how impressive these AI models are. But there's always an issue, how actually impressive is that outcome? Like, we find out, oh, wow, now it's able to do this thing. But is that impressive? Does that really matter? Is that going to move the needle to applications in the real world? Is this going to allow it to act autonomously? It can be a little bit hard to understand intuitively whether any of it matters. So you've come up with a modification of this approach, which I guess you're saying, firstly, you think about a very wide range of different tasks. So it's harder for you to teach to the test, to just teach the model to do one very narrow thing, but then something else nearby or something else that's important to matter in the real world, it can't do at all. Yeah. It just like maybe it can only play chess super well or something like that. So a lot of diversity of the tasks. And then in terms of measuring how impressive the performance is, you think about it in terms of how long would it have taken a human to do, or how long did it in your tests take it for a human to be able to accomplish this task? Is it possible? Are there any like simple examples of the tasks, ones that non-computer people could understand?
There's the ML research ones that's like, train this model to improve its performance on this data set or something. There are more, some very easy, very sort of general research ones where it's like, go and look up this fact on Wikipedia or something. There's some that are, build a piece of software that does these things.
Yeah. Okay. So the substantial tasks, the kind of things that you might delegate to a staff member inside a company, and you've done all these tests. I guess you've gotten software engineers or like people who generally would be able to do these kinds of things and said, well, on average, this takes a human 15 minutes. It takes them half an hour. It takes them an hour. It takes them 2 hours. And you find that there's quite a strong relationship between whether the model can and can't do it and how long it would have taken a human being to do it at all.
Yeah.
Which I guess speaks to the fact that it's hard for these models to like stay on task for a long period of time, or things that require, I guess people talk about coherence, things that require them to think about how am I going to do this over a long period of time. It requires many different steps that have to be chained together. They currently kind of struggle with that. Is that right?
Mm-hmm. Yeah. I mean, I think, there's various different explanations for why longer tasks are harder. Like there's kind of different ways in which they can be harder, right? One is just like there's a longer sequence of things that you need to do, so you need to like get them all right, and there's a higher probability that you'll sort of get completely stumped by one of them. You could also imagine like, either the human just has to like think really hard, or they like try a bunch of times until they succeed, or so that it's not like one totally straightforward measure, but there's also this argument that like as we do more RL training on tasks, it's like much more expensive to do RL training on longer tasks than on shorter tasks, and it's a much harder learning problem if you just get a signal at the end of like what in the middle should you have done differently. Whereas if the task only has like 2 steps, it's much easier to learn like, what should you have done differently. So like in general, there are a bunch of reasons to expect that the models, the shorter tasks will be easier for models, and the models will be better trained to be able to do short tasks than long tasks.
Yeah. And the upshot is you've been able to forecast how long would, it's a little bit hard to say this, but you could say, currently, or like a year ago, the models would have a 50% chance of succeeding at something that would take a typical human 15 minutes. Mm-hmm. 6 months later, they could had a 50% chance of succeeding at something that would take 30 minutes.
Yeah.
6 months later, they have a 50% chance of succeeding at something that would take a human an hour. You're like, seems like it's roughly doubling about every 6 months. I guess, maybe, could you say like what the numbers there are?
Yeah, so 6 months is about right. So we're looking at all the way from GPT-2 in 2019, which can do it's like at a few seconds or something like that, to the latest models. And over that time, there's like a pretty good fit to a doubling of something like, every 6 months. And we also did a sort of ablation where we, both over the actual like noise in the data and over different methodological choices we could make. And the sort of range of estimates you get is basically between like 3 months and 1 year.
Okay.
So I think there's also some correction factor you should take in interpreting this of like, maybe these tasks which make good evals that you can run and score automatically are maybe systematically easier for models in various ways. Like both as the same argument that like that's the sort of thing that you can RL on, and just other things where it's just a somewhat different distribution of tasks. It might be the case that models are worse at them. So maybe that, maybe it like wouldn't, 15 minutes as measured on our benchmark doesn't really correspond to like 15 minutes on sort of more representative tasks. Maybe it would be more like 5 minutes or something. But I think that there is a trend, and that the trend is going strongly upwards at this exponential, rate. So like fixed doubling time, and the doubling time is like, between 3 months and a year is pretty solid.
Okay. So currently the models, at least within these sorts of tasks, which I guess they're unusually measurable, legible, understandable tasks, but they have a 50% chance of succeeding at something that would take a human, would you say 3 to 12 hours?
No. Sorry. So the current horizon length, number is like 2 hours maybe for the best models. But the doubling time is somewhere between 3 and 11 months.
Okay. So we can project that forward and say it's about now 2 hours, and then somewhere between like 3 and 12 months from now, it'll be 4. And then somewhere between 3 and 12 months after that, it will be 8.
Yeah.
And you can project up from there. Yeah. And I suppose it's partly looking at that has made people freak out a little bit, because it seems like within a very foreseeable, not that far into the future, we could imagine that they would be able to accomplish the full sort of work that a software engineer might do in a day or in a week. And then we're talking like actual serious, that would have like more economic applications. Evidently, they're able to act with substantially more autonomy and maintain a coherent purpose over a longer period of time.
And this is also like not, sort of what an average human could do, but like what a human who has all the knowledge for that particular task, right? Because the models they're very much not bottlenecked on sort of generic subject knowledge, and that, they can do all of these things simultaneously. Like I think the difference between, I'm not sure if we've actually measured this, something would be nice to measure. It's like, what is the difference in performance between if you get like the best human to do all of your tasks versus for each task you like pick the best human, and like the thing that we're comparing to the model to is much more like for each task pick the best human. That's a sort of correction upwards in impressiveness that you should do, of like, this is just one model doing all of these different expertise areas, and like if there are, humans are worse at doing tasks that require expertise from multiple areas because like they're not as specialized.
Yeah. Forgive me the mundane operational question, but it seems like this project must have been an insane amount of work, or because wouldn't you've had to hire or contract dozens, hundreds of software engineers or people who are like able to do this quite impressive work on a computer, and then time them and then see like how successful were they at doing the thing. Is it a lot of work?
Yeah. Well, so it was kind of frustrating because we this is slightly off topic to your question, but there was a while ago where I was telling people, hey, it would be really important to get good quality human data like provision for alignment and safety work. And then it was like, oh, actually, there's a bunch of people doing this already. Maybe it's fine, like surge and scale. And none of these providers have been willing to work with us, either because we're like too small fry, or the talent we're asking for is too high, or like we just didn't think they would be, there's others we didn't think would be high quality enough. But yeah, luckily our internal team is amazing and like has made this all happen. So yeah, basically a bunch of credit to them. And I think this is maybe like one thing that METR does well relative to sort of like labs or academics or something, is like having really highly skilled staff doing this kind of stuff that's a mix of technical and sort of operations and logistical work, and being willing to do that. Whereas I think in companies and academic labs and things, I've seen more people like, ugh, human data is annoying, let's just avoid it. And you're just like, even if something is clearly the most useful thing for like pushing forward the research, it's like, I think I'd rather work on like making the algorithms cleverer.
I see, yeah. Whereas you're willing to do the schlep work that actually just seems the most important question to answer,
right.
Even if it's not as intellectually challenging, maybe.
Or like high status in some way.
Yeah. I think, so something that shocked people about this research when you published it, I guess, was that you were finding that the agents were capable of doing substantially longer tasks than what people had previously understood. So you're saying they had a 50% chance of succeeding at something that took 2 hours, but you gave the model access to like very powerful computer chip that it could use as part of its work, basically, and you gave it like a lot of time, I think, to think. You gave it a lot of compute resources, more than people were typically giving when they were testing these capabilities.
Yeah. Right? So we haven't this. Doubling time horizon thing that I've been talking about is not yet published. I think you're probably referring to the RE bench.
Yeah.
So that was like a subset of these tasks that are just focused on like doing ML engineering research. Yeah, so it's things that we do that I think make our benchmark like better quality or get better model performance is, firstly, if you actually compare to humans, often things just like are harder or take longer than people think. Especially in the context of, there's this task and you've like tried to make the instructions ambiguous, but actually it's kind of confusing in this way, or like actually you didn't have the package installed you needed for this. So like having humans actually do them like removes a bunch of these sort of spurious failures. Whereas other benchmarks like SweBench, even SweBench Verified, which is the sort of subset OpenAI did, where they just had contractors look at the task and be like, how long do I think this would take, and do I think this is possible? But I think then when Anthropic subsequently published a thing where it's like, oh, when we ran Claude on those and looked at the failures, some of the failures were still because the task was kind of impossible, because like you didn't, the test cases were testing for some kind of more specific thing that it wasn't clear that was what you were supposed to do. So one thing is just like getting rid of all the spurious failures, so it's a more high quality measure of the model's ability. And then the other thing is, doing kind of like fair amount of elicitation effort. So I think often, I don't know, people have this sort of sense of how much is reasonable to spend on models, which is generally very cheap. But if you're comparing to, well, could you automate 8 hours of highly skilled research engineer labor? It's like, well, that's like, thousands of dollars, right? So if you want to, it would be sad if we were like, oh, models aren't capable of this, models aren't capable of this, models aren't capable of this. Oh, it turns out they're, capable and they're 100x cheaper than humans, right? We would rather know, like, when are they capable of doing it, but it's more expensive and, and you can sort of see the cost going down over time. So we tried hard to kind of give the model fair resources and like benchmark it fairly against humans and sort of have reasonable spend compared to what it would cost for a human.
And the upshot was it was a big, they seemed much more capable than what people had previously thought.
Yeah, I don't know if that's exactly the case. I think it was surprising how well they did on these ML research tasks. I'm not sure that people had sort of measured it that precisely before, so it was just kind of like people hadn't checked this. I think another thing is the case that model performance still has this property that it's very high variance in some sense. Like the best 1% of attempts are way, way better than the median attempt. So I think there can be a thing where you like try and get a model to do something yourself. You're like, I tried like twice and it didn't do a very good job either time. But it might be the case that the model is cheap enough that you could have just got it to try 100 times. And then if there's some relatively cheap way, you can, select the most promising 10 and then, look at a few of them, that then might be way better than the sort of representative impression you got of the model capabilities.
I see.
So we found that, when you do this best of K and you let the model do a bunch of attempts and then you pick the one that scored highest, models do much, much better. And this kind of keeps on, this general result across ML capability evals, you get this kind of log scaling and it looks like a straight line if you double the amount of money you're spending.
Okay, yeah. This is, I guess, a hot tip for listeners is I think I've only recently started getting much more value out of ML models that I'm using just in my work. And I think the big there's two big breakthroughs. One is stick a ton of of good examples into context. Don't just give it one example of an article that you wrote that you liked and say, make something else like this. Put in every single article that you've ever written that you think is good and say, copy this style. The more data into context, the better. Other thing is, I would be used to saying, can you please go away and write one possible example of this and then check in with me to see whether you think it's good. But of course, it's so cheap for them to output 10, 100 possible articles that you could write or blog posts that you could include. So you just get it to output a ton, way more than you would ever reasonably ask a human to do. Right. And then just scan over them and be like, this one, most of these are trash, but this one is really great.
Right.
Yeah.
Yeah. And I think there's a question of, on what range of tasks can you actually do this? Some tasks are just you can just automate this in code because there is some simple scoring function that you can compute. And other things, it's the model would probably be able to recognize a good solution. So you need to have some scaffolding set up that will, then look over all of the things. It has to
look at its own attempts and say, this is the best one of them.
Right. Or you focus your scaffolding on having the model build the tests that will measure how well it did, and then running attempts against that, or and maybe you don't always need to get it down to the one. If you can just prune out a bunch of the worse attempts and then have a human look over them, maybe this is feasible in some situations.
Let's back up a bit. So there's been two main streams of research. One is trying to figure out how autonomously can these models work, and would they maybe be able to survive and spread in the wild? And then there's this other line of research, which is trying to figure out how much are these models helping or able to help with research into machine learning. I guess to many people, it will be obvious why it's very important to know whether AI is good at improving AI. But do you want to just quickly explain why that's kind of a key thing to measure?
Yep. I mean, it just seems like it's sort of both approximately sufficient and approximately necessary for really dangerous things to happen. If you have AI that can automate a bunch of AI research and speed up the progress a lot, then it's okay, especially under the current paradigm where there's no sort of monitoring of what labs are doing internally, you could just very quickly get very high levels of capability that you are not equipped to deal with. And I think the kind of sufficiency, that's approximately the sufficiency argument. It's just this could mean that stuff goes very fast in a way that humans aren't able to keep up with, and that's very strong incentive to automate a bunch of your R&D, and then humans also just don't have oversight of
what's happening,
what data is being put. Just generally what's going on. And the sort of necessity case is something or it seems like the first very dangerous models probably won't have all of the capabilities that they need to take over at the start, but there's some kind of situation in which if they can get some compute and get some resources and are good at AR&D, then they can improve their capabilities on a bunch of the relevant axes.
I see. You're saying, okay, so I mean, just in broad strokes, this matters because it's the thing that would set off a software-based intelligence explosion, because it's a recursive self-improvement loop where it gets better, and so it's more able to improve itself. Yeah. That may or may not actually explode. It's possible that the task of improving its own capabilities gets more difficult so quickly that the process kind of peters out or is reasonably slow and requires a lot of compute. But maybe that won't be the case, and maybe you will see a significant improvement in capabilities very rapidly once AI is doing most of the work of improving it. But you're also saying, at the first point that an AR model might be somewhat dangerous, it might have some gaps in its capabilities. It might have 8 of the 10 things that it would need in order to go and do stuff that humans would really dislike. But if one of the 10 things that it's able to do is improve itself enormously, then it will be able to patch the gaps in its abilities and then go from there.
And then your sort of like dangerous capability evals are no longer really applicable if it can also like
just fix any of those weaknesses.
Yeah.
Okay, so that's why the ability of these models to do AI ML research is a pretty big deal. How good are they in general at doing that work now? And I guess what's the trend going forward?
Yep. So models can definitely do meaningful work here in problems that have this character of like you can sort of isolate this particular task and then automatically check it. And I think there's some question of like how well do the models generalize to the aspects of research and things where you can't do that, where it's like more entangled and you need higher reliability and that kind of thing. Some evidence that maybe it's not that hard to improve models' ability to do for very long and complex tasks is like they're able to do these extremely long chains of reasoning for hard math tasks or something, and like maybe math is very easy to train on, but maybe it doesn't take that much training to get a lot better at this. And then also maybe you don't need, like maybe you can just accelerate AI R&D a lot just on these kind of tasks that are quite easily checkable in various ways. Because like a bunch of software engineering kind of is like this, where you can at least get a pretty strong filter on the solutions. And so like one thing we put out recently is some results on kernel bench, or an extended version of kernel bench. So this is like writing basically like better code to make ML engineering tasks run faster. Again, this is one of the like elicitation is important lessons. So the results on the leaderboard were like, oh, it's a speed up of like 1.01 or like 1.05 or something, which is like, okay, models basically can't do anything useful here. And then Tao at METR worked on this for like 4 weeks, and now it's like, oh yeah, no, models can like double the speed up. That is useful.
Okay, so I don't understand what programming kernels is, but this is something that would enable machine learning research to go faster. Previously, people thought that the models were basically rubbish at this. They could only speed up from a baseline 1 or 5%. But now I guess you gave them access to proper compute. You gave them time. You gave them the chance to do many attempts and then pick the best one. And then you find that actually it can double it. And this is approximating human performance, or?
Yeah, I think it's probably on these tasks, that probably means it's quite a lot cheaper than what you would need to pay humans, maybe like 10x or something. Like I think it would cost hundreds of dollars to pay someone to do this work.
But the model can do it for like tens of dollars.
It's like $30 or so or something like that.
Yeah.
Maybe, and we could probably get that down if we, with more optimization. So yeah, definitely getting to the point where models can meaningfully accelerate research. And I think, already things like Copilot and coding assistants are just writing a large fraction of the code that is written by the models, and maybe they're like not the most crucial hard parts or something, but it definitely is a meaningful acceleration. And I think, just in general, there's just like a lot of evidence that this will just keep going up. I think it's, it's hard to say sort of like exactly where we are now, or like how far could we get with elicitation on current models or with one more scale up or something. And the thing is much more confident is just like this, it's not going to be that long. If you got this like 6 months doubling time or something, the scope of what the models can do is going up pretty fast.
Yeah, dramatically. I think you said to me yesterday that you thought it's possible that the models would actually turn out to be best at kind of the research part of this, or the ideas-focused part of ML research, which I guess to some people would seem counterintuitive, that you might expect them to be best at the more, stuff that is not like one-off insights into things, but rather just like writing code in a way that they've written code many times before.
Yeah.
Do you want to explain why you think that might be the case?
Yeah, I mean, this is a sort of
hot take.
Hot take or whatever, not a super strongly endorsed view or whatever. But I do think people have this reaction of like, oh, but they can't do the models can do this like engineering stuff that's more straightforward. They can't do this like scientific insight or methodology or coming up with new inventions. But I do think a lot of what humans are doing when they do that are like, having read a bunch of research papers and seeing that some method is analogous to some other thing, sort of like nothing new under the sun. A lot of things are just applications of things that are in fact known somewhere else. And like the thing that the models are really good at is really comprehensively having read every single paper and knowing the literature and like having seen a huge number of results of experiments. Like one of the things that we saw on one of our tasks, so the task is basically sort of to figure out what the scaling law is under, there's just like certain restrictions. You like have models of a certain size and you can train them with this much compute, and you need to figure out what the compute optimal hyperparameters are to train at like a level above the amount of compute that you're actually given. And the models didn't always do that well at this, but they're really good at guessing. Like they're much better at humans than guessing what roughly the right number is. And so, there's going to be a bunch of things where models have just seen so many more experiments and so much more data that things like, predict whether this research direction is promising, or like, figure out how to solve this sort of like thorny theoretical problem. We'll be like, in this like obscure field of math and this like, random paper that no one's read, like it turns out you can solve this analogous problem in this way. Like that seems very plausible to me. That is something where models might be comparatively advantaged to humans rather than disadvantaged.
Right. Like it's something that humans struggle to do. And it's one reason why we think, this is kind of magical. And so how would the AI be able to do it? But actually it's an area where it might be their home turf because they just have such broad range of knowledge.
Yeah.
Yeah, the way that people are sometimes skeptical that it's going to be able to have the brilliant scientific flash of insight, it feels like the equivalent of, I guess 5 years ago you hear, but they'll never be able to make great art and they'll never be able to make great poetry. It turns out that's absolutely...
Play Go, whatever.
Play Go. Yeah, it turns out that stuff is actually trivial for them and that they write poetry much better than humans almost. Even really, well, I guess there have been experiments finding that they write much better poetry, even the expert poetry writers, as assessed by other human beings.
Right.
So yeah, I guess it's the technical person's cope to make themselves feel like they're not so replaceable.
I mean, the counter argument is maybe just that this stuff has less of this like easily checkable, more structured. That for engineering. For writing code, you can write tests and you can select for only the programs that actually pass the test and this kind of thing. Whereas you can't, it's harder to do that for research ideas. But I do think I expect the underlying ability in that to be maybe relatively good.
Yeah. So I've been assuming that there would be a software intelligence explosion triggered, or I guess recently I've been assuming it's going to happen within the next 7 years, and 2 years wouldn't at all be surprising.
Yep.
Does your research cast any light on what numbers seem plausible here?
Yeah, those numbers seem very reasonable. I think one number we've talked about is like at what point is sort of 90% of the research oomph going to be coming from models as opposed to humans. I guess one way to be like, when is this starting? It seems like in 7 years we'll be at models that can, do the equivalent of like a year of labor from someone who is expert at sort of all of the things, and also like much faster in serial time. Yeah.
And I guess at that point, I suppose if that trend holds and that is the case, it's really hard to see how you wouldn't have triggered a software intelligence explosion in as much as one is possible, depending on how strong the feedback loop is.
Has a very multiplied the number of people working on this by a very large amount, and you've introduced a bunch of people who workers that have capabilities much beyond humans, and at least in terms of the sort of like cross-domain knowledge and serial speed and things.
Yeah, when I said on Twitter that I was going to be interviewing you, an audience member wrote in with a question on just this topic that I thought was pretty insightful. It says, how much of a bottleneck is labor on algorithmic progress? And how likely is it that we'll automate AI R&D labor with underwhelming results and realize that actually the main bottleneck at that point was compute?
Yeah, I think definitely compute is a key bottleneck, and there is as you automate your researchers, compute is more of a bottleneck because it's also governing how many of the automated researches you can run. But I think there are just kind of obviously lots of areas of lower hanging fruit that you could. It feels relatively clear to me how you would put in more labor and get more performance from the same compute. I do think there is sort of a question of like, why isn't this happening already? And maybe it's more that it's kind of hard to coordinate, as opposed to like there are no humans who are cheap enough for it to make sense.
Coordinate what, sorry?
Yeah, so the type of things I'm imagining you can spend labor on, so there's definitely the like writing faster kernels or otherwise speeding up experiments where this is basically equivalent to increasing the amount of compute. You're just like making your code run in half the time, making your code run much more efficiently. I think there's just like there is a bunch more of optimization that could be done there, and kernel engineers are really good kernel engineers are like rare and expensive. So this is something you could like pour a bunch of AI labor into that. I think other things are like sort of building more tasks and environments and, setting up sort of, obtaining different kinds of training data and things like if having much higher quality data does mean your compute goes a lot further. And this is maybe what things are bottlenecked on, and environments that are sort of rich and interesting, but also have like rapid feedback loops. It does seem just like there's just a bunch of labor you could do to build more of these and build more interesting things here. And like, yeah, there's a bunch of, I know there's maybe some continuum with something that looks more like going out and constructing a task versus like models sort of self play, sort of like challenging themselves to do a thing and then getting feedback from the environment on it. But yeah, it does seem like there's a bunch of ways you could spend compute there. Also, like other things that are kind of equivalent to increasing your amount of compute could be like more closely babysitting experiments and runs and being like, oh, this one, I can already tell that it's not going to be that useful, so I'm going to like put something else in the queue, and then like, let's like cull these ones that are doing less well. There's just like, I think if you just directly ask the question, like, is there somewhere you could put labor in that would speed things up? There's just like, yes, there is a lot of place if it was very cheap, but the bottleneck would probably just be like sort of setting up all the infrastructure to do that and like vetting the quality of all of the data and environments you're producing or something.
Yeah. So the bottom line is compute might end up being the key limiting factor, in which case we will use our AI models to figure out how to get absolute bang for buck out, like to get as much juice out of the compute available as we possibly can. And probably there are a whole lot of margins on which, if compute were the only factor now, I guess currently it seems like labor is probably, I guess both are really important. But if compute was the only thing, then we would just use the enormous amount of labor that we now had to figure out how to use the compute more efficiently.
Right.
I guess even if the intelligence explosion was underwhelming because this turned out to be a substantial issue, I mean, the number of AI researchers is growing, but it's growing very slowly compared to the amount of compute that is being manufactured. I think the amount of compute available to these companies is growing by many multiples every year. So if compute ended up being the limiting factor, you would still expect, or if we went from labor mattering to basically only compute mattering, then that would still suggest a substantial speed up in research progress.
Right. And the sort of like marginal investment in researcher now relative to compute is related to like the price and the speed of the researcher labor. And if they were like a bunch cheaper and a bunch faster, like it would make sense to buy, a lot more.
Yeah.
And you could just like have them. Yeah, there might be a lot of things that's just not worth having humans do at the current prices and serial times that it would be worth doing, with faster and cheaper labor.
Yeah. Okay, just to make sure that we underline the most important messages here. AIs currently can do with a 50% chance of doing something that on a computer that an expert might do in 2 hours. This is doubling every 3 to 12 months. So they're becoming substantially more useful agents. They're able to do things over quite a longer period of time, and it's improving rapidly. They're able to make substantial difference to machine learning research now. They're already used a great deal within the companies. They are probably capable of doing a lot more stuff than is even appreciated at this point. And because if you really try hard, then you can get much more out of them than if you just make a cursory effort. And all of this leads to the conclusion that probably we should expect recursively self-improving AI shockingly soon, I suppose, relative to expectations that we might have had 5 or 10 years ago, that 2 years wouldn't be at all surprising, which is alarming to me.
Yes, I think this is very alarming. I think people should be very alarmed. I mean, I think, there's a bunch of, so scientists in me wants to add a bunch of caveats to the 2-hour number and the doubling time, whatever. But I think, yes, it does seem like it really doesn't seem like 2 years would be surprising. It seems hard to rule out even, shorter, is there like 1% chance of this happening in like 6-9 months? Yeah, that seems pretty plausible. With sort of, the exact shape of the recursive self-improvement, it still seems like we can kind of see a path to sort of significantly superhuman intelligence that doesn't require a sort of mysterious intelligence explosion. It's sort of like relatively clear how you would apply
step-by-step path.
the sort of intermediate capabilities that we expect to get something that's just obviously pretty scary. And there's a bunch of like reasons. Maybe models will continue to be really non-robust in a way that's hard to fix. But like, I don't think we don't care about whether it's whether we're very confident this is going to happen. We care about whether we're very confident it's not going to happen.
Yeah.
And it just feels like we're at the point where it's just like, even if you only care about current humans, like the stakes are very high, like 1% chance of takeover risk, and which itself has 10% chance of human extinction or something. It's just like that's a lot of deaths. So like we should. Yeah, I think we should really care about numbers that are like, whole number of percent. I mean, I think we should care about numbers that are lower than that. But I think basically I would expect the world in general to agree that like it's not worth imposing like, whole number percent risk of completely destroying like human civilization for getting the benefits of AI sooner.
A little bit sooner, yeah.
Yeah.
I mean, I think people in Silicon Valley, or certainly people in the AI industry, these sorts of companies, they've seen these results and they're flipping out, basically. Their expectations are what we're saying here, that they just see a very clear path to superhuman reasoning, to superhuman ability to improve AI, to therefore a software-based intelligence explosion. And so this is kind of the main thing that people talk about in the city that we're in right now. It feels like policymakers, they're like a little bit aware of this. Certainly AI is in the policy conversation a bit, but by comparison, I think they haven't yet flipped out to the extent that they probably would if they fully appreciated what was coming down the pipeline.
Right.
I mean, I guess one of the hopes of the show is to disseminate this information so that people can flip out suitably. Is there anything more you want to say to someone who's in DC who's like, I don't know that I really buy any of this. AI is not my area, or I feel like these tech people are kind of losing their heads a little bit. Yeah,
I mean, it's kind of hard for me to have that perspective because I've just been like focused on AI since like 2017 or something. And it's, sort of was previously thinking that it was further off, or, that I might be totally wrong about this whole thing. But it sort of feels like we've just increasingly gotten evidence that like, no, these concerns are sensible. We're starting to see models like exhibit, alignment faking and all these things we're concerned about. And like, it seems like the capabilities are coming very fast. So I'm just like, this seems pretty obviously the most important thing. Like this is like, even from a very personal, selfish perspective, there's just like, for someone who's young and healthy, this just might be your highest mortality risk in the next few years is like AI catastrophe. I think the other sense that people have that I really want to dispel is like, but the experts must be on top of this, or like the experts would be telling us if it like really was time to freak out. I'm like, the experts are not on top of this. There are like not nearly enough people. Like METR is super starved for talent. We just like can't do a bunch of basic things that are obviously good to do. And in as much as there are experts, they are saying that this is a concerning risk. There was the report, I can't remember what it's called, but the report that Bengio and others wrote was sort of, overall, what is the overall scientific consensus on this risk? And it was like, this seems very plausible that these are, right.
Well,
and I was like,
we're not sure whether we will or won't all die, but it's totally plausible.
Yeah, like to the extent that I am an expert telling you should freak out. Like, and there's not any, there's not especially anyone else who isn't saying they should freak out, basically.
Yeah. Well, it was funny when he said the experts would tell us to freak out. And I'm like, well, the experts in this really are just the people at the companies. And I guess, external observers like you who are like very close to the action. There isn't really a group of independent people who are fully understand all of this and are paying a lot of attention to it in DC in some agency that isn't heavily entwined here,
right?
Who could evaluate this in some more objective measure. So basically, all of the experts actually are saying to freak out. It's just that people are maybe skeptical because they're in companies that are heavily involved and they think maybe they don't have sufficient distance or perspective.
Right. Yeah, I think that's one of the things where hopefully METR can provide a bunch of value is like actually, having the deep technical expertise, but also being independent and therefore more credible that like we don't have
you're not just fundraising.
Commercial incentives or whatever to exaggerate this. So I do think the sort of dearth of experts outside the AI labs is alarming.
Yeah. Okay, let's maybe push on a little bit and tackle a different issue. When I started on Twitter, I was going to be interviewing you. I was actually a bit surprised at the main question that came up. It felt very 2022 to me, but it was, I guess maybe it makes more sense given what we were just saying, which is people were worried that having better evaluations of what the models are fully capable of doing, things like realizing, well, actually, if you put in a bunch of effort and you put in place the right structure for them to act as agents, then they're able to do a whole lot of AI research autonomously with with very little human intervention. They were worried that basically pointing that out was dangerous. It was an information hazard for people to even be aware of this, and maybe you shouldn't be finding that out or shouldn't be publishing it very widely. What do you make of that that concern that possibly your work could backfire?
Yeah, this is something we've discussed a lot internally at METR and, done sort of reasonable amounts of hand-wringing over and, talked to different people about. I think my views on this have changed a fair amount over time. I think the key thing is, do you think of safety progress as static or as a function of the current awareness of AI? And I think implicitly before I was thinking of, there is some safety progress. It's, we're making progress at some rate. And then independently, there is this like capabilities progress. And it's like a race between these two things. I think there's a different framing, which is, kind of just as reasonable, which is like there is some, hype and awareness and, general sort of, what is the current level of capabilities, and both the rate of investment in capabilities progress and the amount of investment in safety and safety progress are both a function of that. So it's like, sort of some kind of speeding up underlying capabilities is not a problem if you speed up the safety more as a result of that, like the relative progress that safety will have made by the time you get to a level of capabilities is now higher, even if that time is nearer. So like, for example, there's a bunch of different ways that this plays out. One is, talent. Like there's a bunch of people who only started working on safety after seeing
what was possible, what was happening.
ChatGPT or GPT-4, some level of capabilities that are like, oh, it's actually time to, this stuff is real, or like, actually, I'm scared of this or whatever. And there's like, policy actions, which are, only going to happen once it's sort of sufficiently obvious that this thing is happening and these capabilities exist. There's the quality of safety research. It seems like you can make much faster progress if you have better models to work with, and not that we'd like exhausted all of the possibilities for making progress on previous models, but that there is a strong effect of your work is more useful when you have better like model organisms of the things that you want to study, and you're sort of closer to crunch time, and you can use models to automate your work more. Like we might imagine that almost all of the technical safety work happens in the period right before, an AI disaster would happen, because that's when you've got the models automating a bunch of the alignment work and things. So the thing that we should be prioritizing much more is like the fraction of investment at that point into safety, as opposed to like when that point comes, because the sort of rate of the background rate of progress in safety is small now
slow
compared to what it will be. There's another factor here that I think is important, which is like compute progress, like independent of sort of AI hype or investment in AI, there is just like Moore's law and kind of economic growth and things happening in the background, which are making larger amounts of compute cheaper and more available. And if you sort of in the extreme case of this or something, we can imagine like, if there's like an alien we know that aliens are gonna dump this like incredible infinite supercomputer thing on us at some point. And like, should we do some intermediate AI research in the meantime, like that, will allow us to like learn some stuff about safety and understand a bit like what is going to be possible. It's like, yes, that seems obviously good. You want, as opposed to that only happening once you already have this like incredibly large amount of compute where you can scale everything very quickly. And it's like, in fact, there is a trade-off where you maybe are bringing the point at which stuff happens forward because like there's more investment in hardware and things, but it's still the case that you would, in some sense, you're like racing Moore's law. If you would rather have all of the things happen, when the chips are bad and when compute is this limiting factor that's like slowly going up, as opposed to like, it turns out anyone in their basement could do this or something like that. And again, that's an extreme example, but I do think like in the intermediate sort of points, this is still true. And then, so that's the sort of case for why it's not, I think it's not necessarily that bad to speed things up. If you're not, if there's some other argument for why this differentially advantages safety, and I think there's just like a pretty clear argument here for why better understanding of what models are capable of advantages safety, which is like by default, this knowledge resides only in the labs, which are specialized in capabilities progress differentially relative to, sort of like regulation and broad understanding and policy and safety and things. So it seems like moving that understanding from being just in the labs where they will happily show it to their investors and things, and that people they're trying to hire, moving that understanding from them to like the broader public who don't love all this racing ahead, or like policymakers. There's some way you could think about the timelines for this is like, you imagine like you need to get a certain level of awareness in time to get like a policy passed before you kind of miss a window that would have allowed you to mitigate this thing in the future. So even if you bring it forward a bit, if you bring the policy action forward by more, you're more likely to kind of get it. Things
have gotten safer overall. Yeah. So the bottom line is, I guess you can have different models of what is racing against what, and the simplest model would be, well, the safety stuff is improving on calendar time. Like every year it gets better. And so every year that you bring forward some advancement in capabilities, that's just making things worse because it's those two things that are racing against one another. But I guess you're saying you think about it in terms of the ratio of, I guess, progress inside the companies to the amount of freaking out and action by other people outside of the companies, which is able to make things safer, or at least get some sort of governance and policy response. And it's only by publishing these sorts of results so that everyone in the broader world understands what's going on that you actually get enough attention and enough concern that the problems can be solved ever at all. And so the worst case scenario is that the companies are fully aware that they can automate most of their work. Presumably, this stuff is much less of a shock to them than it is to the broader world, because they have every incentive to try to figure out how to get the absolute most out of their models to save to save their own money and their own labor costs.
Yeah, I think you should kind of think either we're not making that much difference to relative to progress inside the companies, or METR is just like incredibly awesome and overpowered, and you should join. Because clearly we, are like with like, our like 10 researchers or whatever, we're like beating, these like multi-billion-dollar companies or whatever.
So should we kind of conclude that the companies probably are roughly they were already aware of the results in your research into how good the AI is at recursively self-improving?
Yeah. Basically, that's generally the impression we've got. I think companies kind of like to be like, sometimes give the impression like, oh, everyone outside is totally clueless. Our stuff is far superior. And we definitely have found that often like that's not quite the case. Like our elicitation is like as good or like a bit better. But it's not like, it's kind of like not dramatic in either direction, like, and especially for stuff like kernels where it makes much more sense for them to invest in that specific thing. Like I expect them to be, maybe we have similar understanding, but they've just like, rather than just doing a 4-week project on it and then being like, okay, cool, like we'll just like let people know about this. They would like actually double down on that and, get a bunch better and get profitable stuff out of that.
I mean, I guess there presumably is some downside to this where like maybe the big three are aware of how much they can automate things, or they're roughly aware of your results already, but there might be other actors, other people who are working on AI or nearby who making this more salient is more likely to make them have an effort to automate their own research.
Yep. Yeah, I think that's true. I think also like another concern people have had is like basically kind of related to what we were saying earlier about people irrationally underinvesting in things that are slightly annoying or don't look like the most glamorous, pure ML work of like, gathering data and making good evals that like, that us publishing evals is substantially accelerating companies because they can hill climb on those, even though, so like none of the things that we're releasing have enough tasks that it would make sense to like directly train on them. It would just be a sort of hill climbing, see how well your fine tuning was working sort of thing. And again, I'm like, it feels like if this was the case, it would mean that we should be able to like sell METR's eval producing services for very large amounts of money if we are in fact like substantially accelerating these multi-billion-dollar projects. But I guess the claim here is that people are irrationally not spending enough on evals. So yeah, I mean, and in general, like I want us to try and be like sympathetic to these concerns and like, do a kind of trade and like, like even if we think if we don't buy particular concerns, like try and make concessions to them when it's cheap, but also just like, I think there is a trap of getting bogged down and worrying about like, oh, like maybe this will do harm or something, where all the safety people kind of tie themselves in knots worrying about that, and then like nothing actually happens.
They can't even communicate between themselves, right, or they're not explaining their views to the public properly, or the evidence for their concerns.
And there's definitely something that just, it does feel a bit like sort of overly prideful or something about assuming that your tiny team is like contributing like a large you're like such a small fraction of the total labor and investment going on in this. It does seem like you have to think that you're really exceptionally talented or whatever to be thinking that you would be pushing things ahead substantially.
Does thinking about things this way suggest that you should be trying to write all of your work basically trying to communicate it as strongly as possible to government people or to people who are outside the tech industry, to really explain to them that they haven't appreciated just how dangerous things are or just how quickly things are moving? And maybe the less you can publicize your results, I guess, maybe it's not really imaginable that these findings wouldn't spread throughout San Francisco. But basically, you should be trying to do as much to disproportionately reach people who currently are not being alerted to what is going on. Yeah,
I guess I don't expect it to be that efficient use of labor to try and communicate to one and not the other, especially as, like, I would have thought that, even the people who are not directly involved in the sort of technical world will use what was the general technical reaction to this as a barometer of like whether they should trust it.
Yeah.
And we also we just want eval's research and like understanding of model capabilities and understanding of whether mitigations are good and things to grow and proceed as a field. So, you know, trying to kind of like open source things and you know, be transparent about our learnings and you know, facilitate other people getting funding and support. It's just like we generally want to grow this field, and I don't think the sort of payoff of trying to be secretive about it and then just talk to these particular people is sort of worth, you know, both the sort of effort of doing that and the cost of like not accelerating other people who could be working on this.
Yeah.
Maybe one more point here is just like particularly basically the types of capabilities improvements METR has been doing are very much around scaffolding and language model agents, which, as we're sort of talking about before, it seems much better to have a dumber model that can do a lot of stuff because you've sort of elicited it right and given it all the right tools, and you know, but then you have a sort of this understandable trace of what it was doing, than to just build bigger models which mysteriously start being able to do things but you don't really know why. So I think like differentially pushing forward the capabilities of you know, LLM agents seems actually maybe good.
Yeah, I mean, I guess my intuitive reaction to this concern was just that if the way you're trying to keep us safe, or I don't know, something, an effort that you're trying to make to keep us safe is just to not elicit what the models are already clearly capable of doing, that is an incredibly thin wall of safety. Because just at any point, if someone put in the effort that you guys have put in to figure out how you can get more out of the models, then they could immediately speed things up very rapidly. It's an incredibly perilous situation to be in, where the models are capable of doing far more dangerous things than what people appreciate, or what even the operators appreciate. And then as soon as someone actually spends a week working on it, then they can crack it and do it.
Yeah.
Really, we need to be alert to what is possible as soon as it is possible. Yeah.
Yeah. I think there's some general sort of, people have different feelings about like how competent the world is, which both affects like, you know, what fraction of labor does METR represent, or, you know, like, would someone else do this, or maybe just we're the only ones who'd have an insight or something, and how useful is it to communicate to the world? Will policy makers react in any way that's helpful? I mean, you know, I can definitely see where people are coming from, and I do like think a bunch of these concerns are quite reasonable. I just like overall think it nets out to, this is not a security by obscurity about what models can do is not a great safety strategy.
There's been this interesting discussion back and forth about how likely society or how pessimistic should we be about societal/government responses to crises and problems of all different kinds. I think the first step or the first step in the conversation was, I guess, more technical people saying, like, look at how useless the government is at responding to crises. They like aren't understanding these issues whatsoever. No one's paying attention to it. And then other people pointing out, maybe that's a little bit pessimistic, that the reason that people weren't reacting is that they felt that this was very far off. It wasn't really concrete enough to do anything yet. In fact, you know, if you look at COVID, perhaps we over-responded. You know, the government actually was extremely active once it was apparent. And so the thing is, the thing I guess Stefan Schubert uses the term sleepwalk bias. That the question is like, do we sleepwalk into or through crises? And he's like, no, generally, actually, once it's evident that there's a problem, then you can get perhaps even an overreaction on average, but between among society and governments. Then I'm like, if you look at the situation here with AI, it feels like we're really underreacting. I guess there has been more attention has gone into it. Some stuff has been done. I would say it's barely like 10% of what needs to be done, at least from my point of view. And I think the synthesis of these views is that society doesn't sleepwalk through a crisis, but it does sleepwalk into crises.
Right.
Because basically there's only so much focus that people have. People are very busy dealing with crises that are already unfolding right now. They don't really have much time to plan ahead. And also they don't have the technical chops to understand what things are likely to happen in future. So they tend to just dismiss forecasts that suggest anything interesting is going to change. And so, my expectation is basically we will sleepwalk into a disaster with AI, or indeed almost all kinds of disasters with massive under-preparation, under-investment. And then at the point that it's undeniable that things are going extremely wrong, then you can get a very intense response and a lot of focus on it.
Right.
And there's a kind of a question, is that enough to actually meaningfully change anything whatsoever? I guess remains to be seen.
Yeah. I like, there's a bit in don't look up, where they're, trying to convince the president to be worried about this, incoming planet killer asteroid. And she's like, well, every day I have people telling me the world's going to end for this reason or that reason. On Monday it was terrorists, on Tuesday it was floods, on Wednesday it was the bees are dying. There's some kind of it. I think people can be kind of unsympathetic to that. It is actually even if you are trying to sort of pay attention to the right things as a policymaker, everyone has incentive to exaggerate the seriousness of their particular sort of cause area. And if you don't have the technical knowledge and the sort of disagreement in the technical community, it's actually just quite hard to figure out how to respond. So
yeah,
I know it's
understandable structurally why things play out this way, but it is unsatisfactory. It would be really great if we could come up with better systems for anticipating future problems.
Yeah. And I do think also people maybe have some more of a picture of policy stuff being very bottlenecked on willingness, whereas I think it's quite amenable to more concrete and sensible suggestions that just sort of decreases the amount of sort of willingness that you need by a lot. SB 1047, so that was this bill in California that would have required some evaluations and transparency about them, and sort of roughly as companies to make safety cases. A significant reason, at least that was sort of quoted for why people didn't like that or why it didn't pass, some combination of it, worrying that yes, this particular proposal is reasonable, but in general, it's going to sort of spiral into overregulation, and things will get added on, and people will interpret it creatively. Yeah, and just these evals don't really exist, or people haven't done this before. It's not I think if you're in a world where there was just very clear precedent of this is what you need to do. This is how you make your safety case. This is how you decide whether it is or isn't good enough. This is that would have just made it much easier to get something like this passed, because there's both, there's less of the slippery slope concern the more well-defined the thing that you're asking for is. And it's just, it's just harder to object by being this might be extremely costly if you're no, look, this is, someone has done this already and this is how much it costs. So I do think there are, I don't know, people have this picture of things being very much bottlenecked on lab willingness or policy willingness to do things. And I think there's just a bunch of stuff that third parties can do that makes this much more likely to happen. And even things that are sort of just kind of reminding people and nudging people and sort of project managing things from the outside of being oh, you need to get this stakeholder will help you put together what you need to get this through this stakeholder. There's just a lot of value being left on the table in terms of making it easier for policymakers and for labs to adopt policies that we think are good.
Yeah, I think that was a little bit generous on the SB 1047 case, but maybe I can put to you my impression on it, and you can tell me how wrong I am. I mean, I think what you're saying, that there's concerns about slippery slope, concerns about costs and compliance, that would have made sense maybe with the original draft of it, which perhaps was a little bit sloppy, could be interpreted somewhat expansively, perhaps would have been more difficult to comply with. By the time they had kind of narrowed the scope and drafted it more carefully in response to criticism by the end, it felt like it really was a bare minimum ask. It didn't really feel at all over the top to me, but it still wasn't able to get over the line despite a lot of support among the general public. I guess ultimately it was the decision of one person, the governor of California, to veto it. But the reason I would expect that it didn't get over the line is just the same reason that it's generally very hard to regulate very powerful, very rich, very profitable, very influential, very well-connected, very well-prepared companies. The companies don't want to have their hands bound. They don't want to have all of this scrutiny. They campaigned very strongly to try to stop it. And it's unsurprising, given that they had put so much effort into cultivating the various different political connections towards funding politicians, that this kind of thing is very hard to get over the line until it's unambiguous that there is a problem that has to be addressed. Am I too cynical?
I don't know. For other people, maybe would know more what the kind of real reasons were. My impression is this at least was something that was still being quoted, even towards the end. So it was still like, a useful argument against it was that like, that like this like just compute number of flops was like not a good measure of, is this thing actually dangerous when this, should kick in and various things. So I don't know, maybe this is a smaller on the margin claim that it makes it harder to argue against if you have, good precedent and clear requirements for your thing. I do think there can be other things as well where, just kind of like additional labor can make things go a lot better, where like the kind of lobbyists or government relations people for companies can be out of touch with their company's actual desired policies or whatever. So like, or at least like there's like strong evidence that you could take to them being like, no, look, the company has been asking for this type of regulation. This is like, it's proposed its own version of this. Like, you should be supporting this. And like the people who are the kind of lobbyists and stuff, like really totally are not tracking this. There is some kind of people are just doing their normal thing.
And I guess the thing that they're always trying to do, I guess, is to avoid more scrutiny and more compliance cost and more regulation and so on. So that's their default mode. And unless there's a very strong push inside the company to change that, in this specific case, then that is what they will just naturally want to do.
Like, or outside. Like, I don't think it necessarily has to be inside. Like, I think you can also just sort of communicate to people or make things more salient to people.
Yeah. I guess we should say, I mean, Anthropic with the final draft on SB 1047 was like neutral to positive about it. And I think Dario Amodei, the CEO, explicitly said this would be not that difficult to comply with. The companies that are saying, oh, we could never comply with this are basically talking nonsense. It actually is quite a narrow ask. So credit to them for actually
and I think
telling the truth, I would say.
XAI supported it as well.
Yeah, of course, because Elon's very concerned.
Yeah.
I guess a new topic. I've interviewed, Nick Joseph from Anthropic about evals, also spoken with Alan Defoe from Google DeepMind about evals. I guess both of them, perhaps unsurprisingly, given that they work there, they said that they thought the evals were pretty good, that the RSP, the responsible scaling policy in Anthropic's case, or the frontier safety framework in Google DeepMind's case, that those are actually moving the needle on safety. These are like perhaps not the final form of these things, but they're a very good step in the right direction. Yeah, to what extent do you agree with a more independent, outside of the company's point of view?
I agree that it's like a step in the right direction and moving the needle. I think some things I tend to have disagreements with. I think often sort of individual safety concerned people inside companies have like a rosier picture of how the company interacts with third parties, and sort of like, well, we love safety, so of course we would be supporting all of these things, right? And like, if it's not happening, the bottleneck must be something that's not us, because we really love safety. And I think in fact there's someone had I think Nick Joseph said something like this of like, oh, the bottleneck on getting external oversight of our RSPs is like people who are technically competent to do the evaluations externally, which I like very much disagree with, because I think it like both that I think METR has the technical competence. Like, I think our evals and elicitation and things are like better than stuff that the lab has published, than any lab has published, basically. At least in terms of quality, like where I guess our data sets tend to be smaller but higher quality. And yeah, like we have been like eager to work with labs, and that also like it doesn't necessarily need to be bottlenecked on the technical competence of the external evaluator to literally like run all the experiments and like, set up the compute and things. Just like there's another paradigm where the companies run the evaluations internally and they like write up what they did, and the external evaluator like goes through it with them and like discusses it and is like, okay, did you provide good evidence for this thing? Like, maybe you need to do this other experiment here. Like this, this thing was insufficient for this reason. There are like, or the like an embedded evaluator paradigm where someone from an external third-party org is embedded on the team in the lab that's running the evaluations and is like keeping an eye on everything and making sure that they're not like, sandbagging or fudging things. Like, there's just like lots of things here which we've sort of proposed and been open to, and it's not like, the companies are all banging down our door to do exactly.
To do it.
I mean, I think that there have also been cases where we've turned companies down because we don't have the capacity, but that is significantly because they weren't. We were like, this arrangement would be good and would be worth our time to do, and would take less of our time and capacity. But they weren't offering that; they were offering something else that
something
we didn't think
much more laborious for you. Or?
Yeah, combination of more labor intensive for us, or we just didn't think would provide that meaningful assurance, or wouldn't be sort of improving the standard of assurance provided. Yeah, I think maybe one thing that people have a confusion about METR and have sort of been assuming that METR is a formal evaluator that has sort of arrangements with all the companies to do evaluations for every model, and this is not the case, and that I don't think I wouldn't want to describe any of the things that we've done thus far as actually providing meaningful oversight. There's a bunch of constraints, including the stuff we were doing was under NDA, so we didn't have formal authorization to sort of alert anyone or say if it was if we thought things were concerning. So I think of it much more as we've been trying to prototype what could this look like, and because we're sort of small nonprofit, it's easier for us to be more nimble and try out different things, and it's sort of lower stakes for the labs to engage with us. So that we've been excited about sort of raising the bar on how good the oversight actually is, and labs more kind of want can you promise that you will run an eval on all of our models when we want to, so that we can say we've run an eval on them, sort of thing. And that's not what we're excited about if we don't think that proposed procedure is actually providing sort of meaningfully more safety assurance than not.
Yeah, so I mean, in general, people think that at least within kind of the scope of what you're trying to accomplish with the evaluations that you've created, that they're very good. I haven't heard that many criticisms of them on the substance. And you're saying the companies could come to you and say, we would love for you to run all these things on our models before they go out, and for you to play with it as much as possible in order to figure out how dangerous are they. But they are not requesting that. They're not actively making that easy for you.
We have gotten asks like that from a bunch of labs. I think the problem is, it's usually our goals are sort of prototyping and de-risking what could provide really good safety assurance. So that includes, sort of better governance mechanisms in that this actually feeds into decisions, or at least is shared with the people who are making the decisions. And we have some carve out for being able to say we made a recommendation and the lab chose to not go with that recommendation. Or that employees get to see what was shared with us so that they can check that it was accurate. So there's governance mechanisms that we could be improving on. There's the pre-scale up or pre-internal deployment versus external deployment, where we're just we think this specific time of external deployment is not that interesting, and we're much more interested in what are the best things you have internally, and wanting to know that companies are not building arbitrarily powerful things internally. There's other stuff about just quality of access and information shared about what agent scaffolding has this model been trained to use, and can you share that with us? And what are there, a bunch of stuff that is very important to know to be able to elicit the full capabilities of the models, and things can we see the chain of thought?
I mean, I guess I would say to do things the way that you want it is a lot of staff time, and they're really, I guess they're sprinting all the time in order to try to keep up. Maybe there's they tend to play their cards very close to their chest, and this would involve sharing commercially sensitive information with you, and so they're nervous about doing that, or perhaps that the lawyers at least are nervous about doing that. There are other things that they could say in their defense that have any reasonableness to them, or to what extent would you think it's fair versus maybe closer to being excuses?
Yeah, I think it definitely just is effort. It just would be a thing, and that's maybe there's some ways that it could backfire or something. It's it's sort of the cost is more attention from more senior people at the company or something, I would guess, and sort of thinking how much they want to really do it. I think object level, the kind of confidentiality concerns, it's things we've proposed is like sharing with us anything that's not compartmentalized within the company. And it's like, well, if it's, if you're like 1,000 employees already know this, like 3 people at METR knowing an anonymized version of it is not really going to increase the surface area very much. Or like, the like taking staff time on the inside. Again, it's like, well, it's a much smaller fraction of your staff time than it is of METR staff time. Or like, spending sort of, 1% of the effort that's spent on the model, on capabilities research, on like evaluations, or, a few percent of that effort would be enough to do this. And like, I don't know, especially there's stuff about like token budgets and things, and OpenAI, they had their super alignment compute commitment, which was supposed to be like much larger numbers than like anything that we were asking for.
20% of their commitment up to that point.
Right. 20% of the compute. So it's not like we're hitting, those demands. I think there are a bunch of things which are just technically and logistically challenging for them. If we're just like, can the API please not be broken and like not keep going down while we're trying to use it? It's like, well, yeah, that is just like the sort of before it's like stabilized for public deployment, there'll just be issues. I mean, I think, in an ideal world, it'd be like, okay, you like wait to deploy. If pre-deployment was really the important thing that you needed to gate, you like wait to deploy until you've given your evaluator like proper kind of access, and that they've like had enough time with a stable version of the thing that's actually the thing that you're going to deploy, not something else. It's sort of like, well, you can't directly solve the technical problem of like just make it work, but you can solve the how you're prioritizing, like get a good version of the evals done versus get it out as quickly as possible.
Yeah. So yeah, I guess a cynic would say they're not really keen on having an external group be free to really heavily scrutinize the models, maybe scrutinize their plans for training models that they haven't even trained yet, and be free to notify the public or notify policymakers about concerns that they have, because like what company would want that?
Right.
This is a bunch of risk for them. It's a bunch of stuff that like they're taking things somewhat out of their hands. I mean, these are all of the reasons why you want independent like auditors and so on. But like what company ever voluntarily accedes to that? I guess a more sympathetic take might be companies are kind of always struggling to make things work. This is just another project that could be challenging for them to operationalize, even if they're not that nervous about what I just described. There's lots of good things that they could do that they're not doing, and this is just one of them. To what extent would you adopt the cynical view, or would that be like kind of a fair baseline?
I know I can definitely just sort of like see it from both sides or something. Like I think you could be a company like really prioritizing safety, and this could like not make sense as place to invest your marginal resources. I do think that is not literally the trade-off that is getting made. And I think, individuals at companies who are like, wait, surely we're giving you that access, right? Are sort of not tracking the actual what's happening thing. But, on the flip side, like they're doing much more than you might expect companies just selfishly interested to be doing. I think with different companies, it's somewhat different reason. They're like smaller ones, it's somewhat more just like it's chaotic, and they're they just can't do that many different things at once, and everything's a bit last minute, and the info isn't there. And with the bigger ones, it's like bureaucracy and lawyers and they're like more
decision making is slow in general, and this is a bit of an unusual arrangement. It's not something that they would do with their other products for sure. And again, I think like you could paint this as like willingness of the labs. And I do want to disabuse individuals at these labs who are like, of course we're doing all these great things, right? And being like, no, it's like... You should actually go and check, because maybe not.
Yeah. But on the other hand, I do think we just really haven't pushed that hard yet, because, METR has been like building up our technical capacities such that we can definitely make use of the resources that we're being given access to, and sort of also just capacity to kind of run the standard sort of lab politicking playbook, and like make the requests really clear and accelerate them up the chain, or like get support from a bunch of different people and then make it happen. The sort of thus far, we've more just been doing kind of like vaguely show up and ask nicely and try and be clear about what it is we want. And we haven't gone into the mode of like, okay, like now we're going to actually push on this. And I think this is, this has just been like bottlenecked on talent to be able to do that and things. So I think I'm optimistic about us getting significantly better access in the relatively near future.
Yeah.
Because I think there's just like stuff that you can do to push on it.
Yeah, I see. So yeah, our response might be, well, you've kind of suggested these things somewhat informally, maybe like a little bit last minute, because you've still been developing the evals. You've still been trying to like hire to make sure that you have the people so you can actually follow through on the things that you're asking to be able to do. And so you've like nowhere near exhausted the options to try to get access earlier and more serious access.
Yeah,
and I suppose these relationships could also deepen over time as trust is built, and it's still perhaps at an early stage. Well, I guess it's possibly at a very late stage in the broader situation.
Right.
But the relationship between you and the companies might be at an early stage.
Yeah. I think it is a lot of this thing of like, we don't want to sort of like play hardball if we don't have, some of the folders on us, or, like don't have all of the, we don't want to like ask people to do really costly things and then be like, actually shit, we can't do it.
Yeah. That's totally fair. Okay. A different, though, I guess related topic. Quite a lot of people, over the years, I think many people have gone into working at the various AI companies with the vision that one way they're going to be helpful is shifting the average beliefs of people who work at the companies. Maybe they'll get a chance to talk to their colleagues and convince them that concerns about how AGI might go are more legitimate than they might think. I guess they're also just shifting the weight of opinion within the companies and hopefully moving their culture in a positive, more cautious direction. How do you think? What do you think the track record of that is? Is that a reasonable approach that for people to take going forward? Yeah,
I basically think the track record of that particular theory of change looks pretty bad. I think if you just look at the sort of history of people who tried to do that, there's just like a lot of people giving up and leaving. People have started at one lab trying to influence there and then have kind of given up on that and left. I think there are probably like some people who've done this and it's gone relatively well, but I think they're very much in the minority. Like, I think reasons it makes sense to go to a lab is if you think your comparative advantage is sort of institutional politicking, and that's basically what you plan to do with most of your work. If you're very good at that, I think maybe you can do a better job. Another reason is if you're going to be really kind of like doing the implementation of safety things like at that company. I think if you're just sort of advancing alignment research generally, it's better to be outside of a lab because it's easier to share it with everyone else and collaborate, and like easier for other labs to onboard it if it's not like this thing from a competitor.
I see. Can you elaborate on that? Like, so what sort of work are you describing that would be done better outside?
I think most alignment and interpretability work would be better if it was outside labs.
That's a big claim. I guess most safety alignment technical people work inside the labs now. I guess what arguments have I heard? I mean, of course, they would say maybe it's easier to get implemented on the company's models if you're inside. You have access to more compute, you have access to the cutting edge models, and you need to have access to the very frontier in order for your work to be relevant. What would you say to stuff like that?
Yeah, so I mean, I think the fact that people's choices here don't seem to be that responsive to the quality of the open source models available is maybe evidence that this is not actually driving their decisions. And it's instead other factors. Like I just think that it's, for a lot of research, it's just really not clear that you're actually better off inside a lab in terms of infrastructure and model access, because like lab infrastructure has a bunch of constraints due to security, among other things, and where it's just like actually easier to work with open source models, and you can get like work done faster often, and like especially for open source smaller models are much more optimized. So if you want to do RL or you want to do some experiments with cheaper models, the best ones might actually be outside the companies. And like I know things like, anyway, I feel like it's a big shame that Anthropic's interpretability research was not on open source models that could then be shared, and people could kind of poke around with it. And I think like in terms of just actually paying for clusters or something, I think funding is that there's enough funding available. I don't think that's going to be a huge bottleneck unless you're doing massive pre-training experiments. Or I don't think I think there's like not a crux in most of the cases. I also think maybe this is less true now if we are just close to the end times, but in the past I would have said, like, okay, if you think that your research is much more productive if you have access to the very latest models, then that also means that the research you're currently doing is just like really unimportant compared to the research you'll be doing like in a while when the models are better. So like you shouldn't really
because it will be superseded.
Right. Well, it's just like if it is the case that your research is much better with today's models than last year's models, it's also the case that either there is something special going on about this particular point in time, or your research is also much less productive now than it will be when you have the models a year in the future, and like much less productive again than the models a year after that. So like this, like if you believe that it's very important to have access to the most cutting edge models, then that also implies that your research now is like a small fraction of the total value that your research will provide when you have access to these more advanced models. So that suggests you shouldn't really be prioritizing like what allows me to be most productive on research now. You should be
just preparing yourself to do work in future.
Yeah, or like, prioritizing like buying as much time as possible at the point where you have these models that really speed up your research, which maybe points to like working on evals.
I see. Right. Okay, so just to reiterate some of that, you're saying, I guess people have definitely make the argument, oh no, I have to have access to the frontier model trained by the best company in order for this to be relevant at all. Like I suppose you had one objection there, which is like, if all that matters is like what's done on the frontier model, then maybe what really matters is what's done at the precursor model just before these models are truly dangerous, and everything now is going to be kind of by the time we get to that stage. But also, there's been I guess these days it seems like the best open source model is virtually as good as the best closed source or closed weight model, the ones that are inside the companies, or at least it's nipping at the heels of those models as far as we know. In that case, the argument that I need to have access to the very best model is much, much weaker than it would have been, because you could just download R1 and just run it on your own computers. And I suppose you can imagine inside the companies, you have to bid for access to compute. You have to coordinate with a whole lot of other people and getting access to and
like
authorization.
A bunch of security setups, which means you like can't easily run open source models on
Whereas you could just buy your own H100s, buy your own chips, store them in your own office, and then like download R1, and then you could just start doing whatever you want with a tiny group that's committed to that. And I guess that might help to explain why it is that groups like Redwood Research have managed to really kick ass. It seems like their research is remarkable, given and they're not working. I mean, I guess they collaborate with the companies, but primarily they're operating independently.
Yeah, and I think this has been the lesson of people who've sort of done research inside and outside of companies, is like not clear that the internal access allows you to make research progress faster.
I mean, another argument might make is that it seems like most people have tried to go inside the companies, so perhaps there are neglected opportunities for people to not be inside the companies. That kind of the weighting is like really 80-20 in terms of So I think I had 3 reasons for being inside companies that I didn't finish listing. One, if you actually really are into being a sort of political influencer person, and that like that is your skill set and you're going to do that. But then the other 2 I would list are like you're implementing things, like not sort of doing the general alignment research, but just like making sure that this actually gets into the production system, or otherwise sort of being very close to the sort of stuff that's actually happening and being like, oh, if the company isn't cooperating with third parties, I can at least like run the evals, and then like, me and my friends will know whether we should freak out or something. There's some kind of, if especially in worlds where things are not going very well, having some people inside the company to trying to actually, get the basics implemented is useful. And then I think that the third one is like, sort of similar, like basically like being the sort of person who would whistleblow if there were egregious violations of things, and like getting into a position where you like have awareness of that information and like, I think a lot of the
actual mechanisms for regulation or oversight to work do require that you trust the company to not just like completely lie to you or give you totally misleading information. So I think it's like very important to have some number of people internally who would have the guts to whistleblow if like the lab was feeding misinformation to regulators. And I think, I don't know, that does in fact take a lot of guts, as evidenced by the, stuff about the OpenAI secret non-disclosure agreement that no one
hundreds of people put up with it, and then it took like one person who's really stubborn to dig in their heels and say, no, I'm going to make a fuss about this. Kudos to Cockatielo.
And Will Saunders. So I think, if that's your sort of theory of change, you've got to be pretty confident that like you are that sort of person. And I think there is sort of some correlation between the sort of person who's like, oh, well, like the lab is offering me the most money and it's like, convenient and high status and cozy and has, comes with all the benefits. I guess I'll go there, and not being the sort of person who's actually going to whistleblow, and that there's some kind of selection.
Yeah, they might filter against someone who seems especially whistleblowing prone.
I do think labs also just like actively filter those people out. So,
I've maybe been surprised the degree to which they're willing to hire all comers, or it doesn't seem like there's really intense filtering on kind of personality type. It's not maybe like going and working at the CIA. It feels like in some ways there could be more scrutiny on people's motives. Yeah,
I do think there is a, moderate amount of selection against having too strong principles or something.
Yeah. I guess that's true in companies in general, that they often don't want to have firebrands or people with a strong independent agenda. But I guess you're saying that is also somewhat true here.
Yeah. I mean, it's just like reasonable in many ways. Like often those people are in fact unreasonable. And like, there's a sort of unilateralist curse of, people who are going to be unilateralists will, in expectation, do unhelpful things. Yeah. So actually implementing research or sort of being whistleblower are things that I think make sense to be inside a lab for. The reasons that I think, people go there for reasons that are less good. One is this like, I'll influence in a good direction, which I just think has a bad track record of effectiveness, versus influencing from the outside, which I think has a much better track record. One is this like, I have to have access to the latest models, where I'm like, I don't know, I don't really buy that. I think people also like, I think you should, naively one would expect that like relatively too many people go to labs and to than go to nonprofits or governments just because it's like a nicer job in other ways, like it, and they have more experienced and aggressive recruiting departments and this kind of thing. Like you just like, they like pay way more than government and have better like benefits and stuff, and it's like a more of a high status job in general, and you maybe get like better technical mentorship than being like some of the founding people at a smaller org. But like, I also think this one is a bit, I think people are sometimes wrong about how much growth you get from just like go and try and do the thing yourself, as opposed to like, be in a larger organization with people who are better at it than you, like, and you grow most rapidly from just doing the thing. And someone's like, oh, I want to go to a bigger org to grow my leadership skills because I can learn from other people. It's like, I think you would grow your leadership skills more by just by leading this thing that's right here that needs you to lead it. Like, so I don't know. I think there's some amounts of motivated reasoning. And generally, I think like, if you think, unless you have a particular reason to think that you would be a particularly good fit at a lab and not good fit at nonprofit or government, I think you should probably not go to a lab.
Yeah. Just as an aside, it's interesting that you call them labs rather than, I guess I switched to calling them companies at some point because someone pointed out, or just asked the question, these organizations, do you think their primary nature is as a research laboratory or as a company? And I was like, yeah, I mean, obviously, I guess it's as a company. Or, maybe at some point long in the past, they were primarily research laboratories. Or that was the right way to think of them. But it feels a little bit hard to see that now.
Yeah, I don't know. This is not an assessment of what I agree there are companies. It's just how it's fewer syllables.
Yeah.
Yeah. I do think it does make sense to have, at least a few people who really care at each lab who are, sort of can be implementing the basic mitigations, can be running the basic evals, can be sort of keeping an eye out for egregious misconduct. I just don't think that like everyone piling into the labs, if you're just generally doing safety research, sort of like public good safety research, makes sense.
Yeah.
Or if, for some generic, like, I'll just like be there and influence them in a good direction. If, like, I guess I feel like I see this a lot from people who are like, it's like, but you're a really introverted technical person. And in fact, in practice, you just spend like 8 hours a day coding. You're not like, it clearly doesn't make sense as a specialization for you to be like, I'll be here and influence things.
Yeah. So I think you told me earlier this week that METR's strategy has over time, I guess, changed to adapt to what is somewhat more pessimistic or challenging situation. Can you elaborate on what you mean by that?
Yeah. So I think this is more relatively recently feeling like timelines seem short and, we're not in some of the best worlds in terms of how much is getting done on the safety front. So I think originally when we were sort of designing what would become RSPs and thinking about what evaluation regimes would make sense, we were imagining the idea of something like, you want to keep the overall risk of, catastrophe, end of civilization from AI below 1%. And then, and if there's several labs, they each need to be a bit below 1%, and any particular deployment probably need to be below like 0.1% because you're going to get multiple shots, etc. And I know this just seems like what is reasonable from a societal perspective. I think like personally, I care about future people also, and so I think the risk we should be aiming for something lower than that. But I think even just from the perspective of people alive today, want the risk. The benefits of getting AI sooner aren't good enough to justify much higher risks. But I think we're increasingly in the world where, it doesn't seem like we're going to be keeping the risk that low. Like I think we can sort of describe what you would need to do to be in that regime, and I don't think that we're doing it. That the world is doing it, and maybe our work is less useful if we're pushing on things like, okay, how would you make like a really robust safety case and that would have like good external oversight? Maybe this is in fact a distraction from like, okay, but can we just like do the most basic mitigations, and maybe we don't even have time to like check if they're working, but like let's at least do them or something. Like get the sort of like getting the risk from 30% to 20% or something like that. Maybe is more what we should be focusing on.
Okay, so the basic difference is you could spend a whole lot of time laying out what would be absolutely ideal practice that would get the risk down, 0.1% or lower in aggregate. But if we're not even doing the absolutely most basic stuff already, then the stuff that would bring it from 30% to 20%, then obviously I guess you would focus there because the impact is way, way larger. And I suppose those are also the marginal changes.
Yeah. I think ideal practice even is too strong. I feel like the ideal thing looks way more intense. And this is just the sort of like, in some sense, like the bare minimum from a reason, if sort of society as a whole was making reasonable decisions, that I think would be sort of roughly what everyone endorses. But going from that, which looks like being quite careful, to just, trying to on the margin get the risk down a bit.
Yeah. So you think the risk is like 30% on like the current track that we're on?
Yeah, I usually say something like 50-50 in terms of, do things go broadly sort of go well? Yeah, like do we capture sort of most of the value of the future, or do things, and so like not all of the 50% looks like, obviously a disaster for currently alive people or something. It might be some like, lock in or more gradually going off the rails or something like that. But I think a bunch of that, a bunch of that is just like sort of war and catastrophe and AI is taking over, and it's like very clearly everyone agrees this is bad sort of territory.
I guess there are a handful of people who like that, but
yeah,
I guess it's a distinct minority. So starting from that picture where like almost not even the basics are being done, what is the marginal thing that you think, like what would be your probably next ask given the situation that we're realistically likely to be in a couple of years' time?
Yeah, so there was the thing we were talking about earlier of chain of thought faithfulness and like actually looking at the chain of thought. So just like doing basic checks for alignment of just like, have we looked at a reasonable sample of the reasoning the model's been doing and been like, can we understand this? And like, is it blatantly reasoning about how to trick us or do bad things or something? Like that's one very basic thing I can imagine is just like
something
neglecting
that extraordinarily
to actually
we could fail to do.
Yeah. And another intervention would be making sure that we keep the chain of thought interpretable, which might be like, oh, we found, companies might find some fancy new way to get more performance out of the model, but it now means that it's just like neuralese and, humans can't read it at all. Like that would be very sad. So if on the margin there are some techniques that we can do to either ensure that we can interpret that or to sort of bring the performance of the interpretable thing up so it's less of a hit relative to the uninterpretable thing, like that would be pretty good.
I guess neuralese is this term for like gibberish reasoning by the model that I guess is useful for it to reach a conclusion, but humans can't make any sense of it.
Yeah, this could also just be like it's just, passing numbers to itself. It's not even like outputting tokens that look like words or anything. So yeah, like it feels like we're in a much better position than we might have hoped to be in terms of having models that do a lot of their cognition through legible reasoning. People are working hard on making that not the case. That's one thing that feels like it just gets a big, increment on risk, how you handle that. I think there's just a lot of other sort of very basic, what risk of misalignment are you incurring stuff? Some combination of like, what is your training data like and how much are you incentivizing the model to sort of knowingly lie and reason about what the humans want and reason about playing the training game? How much benefit is it getting from doing that?
I was just about to ask, is it actually imaginable that we could be so stupid as to just penalize, like look at the chain of thought, find out when it's scheming, and then just negatively reward that and try to discourage the visible scheming?
Right.
I guess people don't realize the trouble with that is that it could just cause the model to become like cleverer about hiding its scheming. It doesn't necessarily actually reduce the scheming. In fact, probably it would just cause it to become more surreptitious. So that's actually a negative thing to do rather than a positive one.
Right. Yes. I think, back in the olden days of AI safety, people used to worry about like, having a sudden jump in intelligence that models would go right through this regime where you have models that sort of scheme, but they're not smart enough to have it not be detectable for us. But I feel more confident that we're already seeing models that can do this. We're going to have some period of time where the models are smart enough to do this, but not smart enough to hide it. But the thing that I worry about is like, we're going to see signs of egregious misalignment, and then we're going to sort of be like, maybe that was just noise. Let's like train it not to do that. Let's slap some patches on it, so that we like totally will have had evidence, and it'll just be ambiguous enough once you try some sort of superficial fixes to make it stop doing it that we won't, really do things differently based on that.
Yeah. At a high level, really overall, how responsible versus irresponsible would you say the main AI companies are being?
Yeah. Like, the tricky question in some sense is sort of like, what is your reference point? Like, I think from the perspective of what I would think, humanity in general would sort of endorse if they knew all the things, and what a sort of reasonable society that could actually coordinate would do. I think they're being like extremely irresponsible, and like from my personal perspective, like even more so, because I like value future people more maybe than the average person does. But on the other hand, like if you look at the individual incentive structures around the companies and like, a bunch of, all these companies have a bunch of really good people who are working really hard trying to make things go well and like within, understandable constraints. And I think there's like a bunch of arguments under which it does make sense to trade off safety for going faster. If, you're worried about misuse by authoritarian regimes or that sort of thing. Or if you're just like, we are going to dedicate, more effort to alignment. So it's good if we're I think there's just sort of, there's less of people being like locally people are pretty reasonable, or at least, a lot of people are reasonable a lot of the time. I think people are also definitely unreasonable, but overall the situation is like very bad.
And it sounds like you're saying that's primarily because of the lack of coordination, that if you just only had one organization that was thinking about this from the perspective of, even just like all people alive now, then probably they would go a lot more cautiously and they would invest more in these kind of evals to figure out what's going wrong.
Yeah, I think it's partly the coordination thing. I think it's also just that humans are bad at dealing with uncertainty and with probabilities that are smaller than like about a half or something. When I was at OpenAI, there are a lot of people who, if you ask them the right series of questions, would say, yeah, the probability that the like thing that they were working on would lead to killing all humans or something, you'd get like 10% or 20% or something, but it just like wasn't really connecting. People, and I think like if you actually want to keep the risk below 1% or even lower, it looks like being very cautious in some sense, because our uncertainty around possible threat models and around like the sort of error bars on our capability assessments and all of these things are so large. Like being 99% confident that this is fine is like a high bar, and it like I think like model releases now are getting to that level, and it's like, okay, we're like very confident that it's fine, but like very confident, maybe that's like 95% confident that it's not going to do anything super bad, and maybe it's like 99 or 98% confident that it's not going to be catastrophic, but it's pretty hard to get that low.
Yeah, and so the issue there is that if you want to get to really low levels of risk, 99.9 or 99.9 or 99.99% confident, then you have to be really sure that there's nothing outside of your understanding that's going on. Because even from your perspective, given your dominant understanding of how the models are working and what they are and aren't doing, things might seem 99% safe. There's always a possibility that you're mismeasuring things, that your evals aren't capturing what's going on. Maybe they are figuring out how to understate their capabilities, and it just makes it exceedingly difficult to really bring risk that low when you have such an unclear picture of what's actually happening at all.
Yeah, and I think again, I'm not really thinking about the like 99.99. I'm more thinking about the can we get to like
10 to 1%?
Yeah, something like that. And yeah, again, it's not like, oh, we have pretty detailed understanding, but like maybe we're wrong. It's like, no, we just have gigantic error bars, and we're just like, yeah, we don't, we're very like, yeah, we really have no clue. And like, the companies have described themselves and their safety processes like building the airplane while flying it or whatever. It's like, it's not like, oh, we're being so cautious, but like, we're trying to reach this really high burden. It's just like, yeah, everything is a complete mess. And like, it's, pretty hard to keep, we've got to work pretty hard to keep the risk to what would be an at all reasonable level. And by default, it's going to be way higher.
Okay, pushing it from that, people are working on all kinds of different research agendas, I guess, around safety, control, alignment. Are there any of those that you want to shout out as maybe particularly underrated or particularly overrated, maybe things that people are over-investing in? And perhaps, I guess a worry would be everyone like herds into some particular research agenda that's fashionable, but it's actually not really going to move the needle in the end, and that could end up being a huge diversion of people's attention.
Right. I think there's both a question about what is most important to work on and where, or sort of like in what way. So I think the things that I'm most excited about people working on are sort of somewhat, there's a sort of like very concrete implementation of at least getting the best practices we're aware of thus far into sort of production models and trying to maintain that as an invariant, that we're always getting the best alignment techniques there. And there's like generating new directions or like creating model organisms to study or stuff that's more like research. So I think one thing is like I think it would be better if way more of the public good research was happening outside labs. And like I think Redwood research, despite being 2 people, has really high output compared to the entire rest of the field. And like all of the people at labs. And like the stuff they've done is really good. Like I think control seems good. Alignment seems good. Generally understanding scaling laws and forecasting and eval stuff seems good. I think one thing that's maybe, in my opinion, is somewhat overrated is interpretability. Like, not that this is not useful. Like, I think there's a bunch of ways it's promising and good. It's just, it does have very high investment currently, and I'm not sure it, deserves as high investment as it has.
Okay, so that's one approach that you think we're a bit over-invested in. Is there another one that you think is more promising than people have appreciated?
Yeah, there's some general direction of just getting the capabilities that you want and not the ones that you don't want. That I think currently I feel like how labs are going to react to evals, they're just going to build more capable models, and then it's going to be like, now it's more capable and it's maybe going to trigger this thing, and then
what a shame.
Maybe they're going to fudge the evals, or maybe they're actually going to do some of the mitigations or something. But it's I don't think people are. I think we could be trying much harder to be like, okay, what is it that we, what is the reason for rushing ahead and building these models? It's because, the sort of argument is like, oh, then we can use them to do safe things and protect against these other models, right? Like almost all of the companies that are like, building AI is important is like because someone else might build it, and we've got to protect against it. But I feel like this is very disconnected. I would rather the world was like, okay, maybe some people are going to build dangerous AI. Like, how would we protect against that?
What would be the minimally capable AI that would be really helpful?
Or just like, maybe the most important thing to do isn't even AI. Like, it's not super clear that that's what you need to do. Anyway, I mean, I think it's, there are sort of reasonable arguments for it being like, oh, we have a bunch of uncertainty and you just want to have a generally capable thing. But I just feel that people sort of aren't trying at all to be like, how could we get the capabilities that are most useful, and like which other capabilities can we knock out? And this is some of the sort of like very basic control stuff of just you can be more confident your model is not capable of taking over if you there's like a ton of stuff about the world that it doesn't know, and maybe it's just like it's like really good at coding and stuff, but it just doesn't know anything about sort of world events past 2010, and it like you really tried to remove everything about computer security and something something like that, where it's like, oh, this model couldn't really do stuff by itself. It's only worked in this like lab setup where we give it all the right things or something.
Yeah. So I guess the case where I've heard this discussed the most is trying to not include cutting-edge biology, I guess in particular cutting-edge virology or microbiology in the training data, because that's the kind of thing that would allow it to design a bioweapon. Yeah, and it's a fairly clear point to make that why does the model need to know all of this incredibly cutting-edge biology unless it's being used by virologists?
Right.
Who, and in that case, why not just design a very special model for them that only they have access to? Why does the model that is going out to retail customers like that us have to know the most dangerous things basically known to humanity up to this point?
Right.
And you're saying this could generalize quite a bit more, where you could hobble the models by ensuring that they're lacking specific capabilities by simply never training them in it. Specific things that would be useful for them if they were going to try to scheme against us or engage in activities that we don't like. And I guess I haven't really heard that approach discussed very much outside of the biology context. Maybe it is talked about with, I guess cyber stuff would also be another classic case where you could maybe use this, although they do seem to need to know a lot of coding for many commercial applications. So perhaps that's trickier. Right.
I think it's easier for the narrower things, but I do think if you need it for some applications, you just don't need to serve that capability to everybody all of the time. And, with the bio stuff, if you might still want to support synthetic biology research, but that's like an extra training phase that you add on at the end, and then you serve that model only to a like very carefully selected group of people and things. So I think even if you need the capabilities, sometimes we could still, be sort of the kind of frontier of which capabilities are how good that we're targeting or we're sort of really not trying on this in a bunch of ways at the moment.
I do remember hearing people push back and say the trouble with this, just excluding some information, is that it would be able to, like, I guess at the point where they were producing even more capable models than we have now, they'll be able to interpolate and guess lots of stuff that you left out. Like if you just if you included everything other than the news in 2013, then probably it could just guess what happened in 2013 by knowing what happened later. And I suppose even if you didn't include anything after 2013, it might be able to guess a fair number of things that happened simply by the information that it has up to that date.
Yep.
To what extent is that a serious limiting factor?
I think, this isn't a super robust intervention. This is, a sort of
Here we're trying to get the risk from 50 to 40%. I see.
Sort of world thing. I do think there just might be more technical work to do here on how can you actually like remove knowledge or capabilities from models, or figuring out how much they can infer, because I think you probably can assess this reasonably well, even if you have some concern about sandbagging. If you're just trying to figure out, does the model have this basic knowledge, then it seems like this is kind of a whole thing. There's like some level of sandbagging to do it with RL, and there's a much higher level of intelligence that's demanded to do sandbagging if you're just doing like classification fine-tuning. So it's kind of like if the model does in fact know the answers to a bunch of questions about this, you should be able to see that, like, with fine-tuning it like picks this up really quickly. So the answers must have been kind of like already in there. So I think you can kind of tell what models know in this sense
by how quickly they later learn how to.
Yeah. And also, like, as we were talking about before, if you don't actually have great security, what you do want to know is it easy to fine-tune the model to have these capabilities? Not like, does it demonstrate them right now these exact weights.
Yeah. Just to clarify for people who don't know, sandbagging is models pretending to not be able to do things that they actually are able to do, or basically kind of any like lowballing what you actually are able to do. I think it's actually from sport, where people, it's a sport term, I think, from people who are, I guess, like throwing a match, basically.
Yeah.
Wasn't there some work on forgetting? Wasn't there some effort to try to get like a model to forget the existence of Harry Potter? And I think they managed to kind of successfully do that, or forget something or other.
Yeah, I'm not familiar with that exact thing, but it sounds plausible. Yeah, I think people have done some on this, and like, I sort of call it like unlearning.
Yeah.
I just don't think I just haven't seen that much on it, and in particular, I haven't seen any kind of application of it.
Yeah, I think I've heard about that in almost a year, which is a bit of a shame. Yeah, is there anything else you want to call out as potentially underrated?
I'm sad that there's not more work on helping humans evaluate difficult model outputs. Basically, like the stuff I used to work on, debate and IDA and these kind of, there's a whole genre of sort of alignment research is like, how do you make sure that your model is not doing destructive things when it is smarter than you are, and how can you create structures that provide a systematic advantage to the rater? And like debate is one of these where you sort of like have copies of the model and they're debating with each other, so it is hopefully much easier to like, you have some specific sub-question that you can judge, and you can judge how each sub-question relates to the question above, and like this is much easier than deciding the overall answer. And I think there's just like, there could be a lot more stuff, and just helping humans more quickly make good judgments about, was this actually the behavior you wanted? Was this actually, seeking power in some undesirable way? That I think both the more faithful your training signal is to sort of things like truth and honesty, like the less incentive you are putting on the model to reason about the training process and the flaws in the training processes and things. And the more you have these techniques that kind of amplify what humans are able to evaluate, the more you might be able to check, like, is your model, we're like, oh, these models are, they're like running all of our security against these, like rogue, unsafe bad models that someone else has developed. We have no idea what's going on. We don't know whether our models are actually secretly cooperating with the rogue models. Just like the better you can be like, oh, we have this scheme to have, two models adversarially evaluate each other and point out the things that they're doing that are most suspicious and then evaluate those. Like the better we are at that, the more able we are to train for actually do the thing that I want.
Yeah. You said something a little bit spicy earlier, which is that you think possibly Redwood, with just a handful of people, is maybe producing about as much alignment research as all of the major companies put together. But I assume that's not actually literally true. But yeah, what do you think the barriers are to? Maybe you do think it's literally true. What would the barriers be to the companies being more productive in producing more alignment publications than they are? Because it's a little bit hard to understand because the resourcing would be so uneven there.
Yeah, I mean, I may be biased in what I'm exposed to, so I'm just much more aware of the stuff that Redwood has done. But it's just actually not implausible to me that is the kind of current ratio. I think. So reasons companies are less productive. I think. There's stuff we mentioned a bit before about maybe actually the infrastructure and speed at which you're able to do research is slower. I think there's different incentives and pressure to do the thing that will unblock shipping the next generation model rather than do the research that's most important in the longer run. I think to some extent just too many people in the same place or something, where it's just a marginal person is less useful when you already have a ton of people. I think also, maybe companies are more focused. This is similar to short term. It's both short in terms of time horizon and sort of locality. They're just thinking about things at their own company and not being what is most important for the field as a whole and how do we disseminate that and make it easy for other people to adopt. And there's a bunch of barriers to publishing, and that's maybe a reason that some people have been unhappy about not being able to publish their work enough.
I see. Yeah. Okay. So presumably that they're a lot more cautious now about what they share and what they publish. And I mentioned there's a lot of levels of review that stand between someone having some insight and it going out. I guess especially if it's related to risks that the company might be creating, you can see a lot of people wanting to scrutinize that before it's shared.
Yeah. The sort of comms team in there editing the blog post, being oh, this sounds. Can we make it sound a bit more optimistic here? I guess maybe another thing that I sort of think is overrated, or I feel like sometimes people conflate alignment in the sense of making sure the model is sort of trying to do what we want and not trying to do extremely bad things that we definitely don't want, with making the model better at following complicated instructions or other things that are kind of more just making the product better or enhancing the model's capabilities in the direction of following elaborate rules about what we want. And this is just not, I would just be more excited about progress that's progress on the problem when humans don't know, which output is better, but the model knows a bunch of stuff about what's going on. Seems more useful than the humans want the model to follow this complicated set of instructions, so we did the things to make the model better at following the complicated instructions, because otherwise it was forgetting that it's supposed to also have this policy or something. I'm just it doesn't feel like it's making progress on the core problem.
Yeah. Did you say earlier that it's you talked about neuralese, which is this sort of internal gibberish to the model we can't follow? It's helping it solve the problem somehow. Is it possible to have a science of interpreting neuralese to go from a bunch of numbers that the model was able to understand back into English in a faithful way?
I think that there's some of this which is basically contiguous with existing interpretability, and it's sort of you've just gone from your model, doing single forward passes to your model to now you have some recursive thing and you're just feeding the activations back in and sort of basically you want to do all of the same interp things. I think there are also other approach is if we're talking about specifically this case where like you did have an interpretable chain of thought, and then either you trained on it too much and got gobbledygook, or you sort of did some kind of optimization. That there's maybe a bunch of techniques here that's sort of more like preserving the existing interpretability that you did have, as opposed to sort of recovering it from this thing that started off completely unchangeable, or making it possible to get that speed up without needing to transition to the neuralese.
Right. Well, I guess so. That would be the trade-off. So the reason companies will allow that to happen is because they just think requiring us to be able to understand the reasoning is merely holding it back. We need to allow it to use its own gibberish because that's better. But I guess if you then added a whole other layer of requiring it to then translate its reasoning back, then that's just slowing it down again. So, I mean, I wonder, is this an area that might be right for regulation, that you should say you can't have models just using, or maybe there's always going to be too much of a gray area of whether the chain of thought is comprehensible or not, and so it's not a very like bright line that you could draw in the sand. But it does feel like it would be really nice if we could get them to act in the spirit of saying, you always have to be able to, no neuralese basically.
And like no training the model not to do kinds of reasoning that you don't like. No training the model not to reason about scheming. Yeah, and it needs to be interpreted. I mean, I feel like it would be great if that was enforced. I feel like that, I do think there's a bunch of opportunity for technical progress here where you could, it's maybe much more feasible to figure out how you would have some kind of summary or translation that you were ensuring is faithful in some way. It just feels like a thing that people could work on.
In terms of common sense regulations that you could try, I've had the shower thought for a while, which is, why not just, this is going to sound, to the regulatory scientists, this is going to sound stupid, but why not just say ban AI being used to enhance AI? And then I'm like, I would feel so much better about the future if I knew that you couldn't have a recursive self-improvement loop. That would solve the problem to an enormous degree. The problem, of course, is it's already being used that way. They're already using it to help with coding. They're presumably already, using the language models to just research all kinds of random questions that they have, and so it's assisting. But then I think if you just had that as the rule and you interpreted it kind of anyway, any plausibly reasonable way where you draw the line between what is and isn't permitted. So you're like, you allow some basic assistance with programming, but like nothing that's more impressive than what we have now. I think it would be a massive improvement, basically. There's almost like no way that could be worse from a safety point of view than the default where we just completely allow, like, there's absolutely no rules about that whatsoever. What do you think of these kind of naive things that, a person off the street who was just presented with this problem saying, well, why don't we just ban the thing that's like obviously creating this enormous risk? Can we get some mileage here?
Yeah, I mean, I'm maybe not the best person to ask about like regulatory feasibility or whatever. I think it's, as you said, it's like hard to, if people are already doing things, say that they can't do it anymore. I would be maybe worried if there's some overhang created here, if people were just holding off from doing a thing, and then you suddenly get a lot of improvement. But I guess
people would say, "Oh, China's going to do it anyway. This would hold us back so much."
I think there's stuff you could do, like the amount of trust you need to have in your model before you let it do stuff, or some level of. I think more just models above this capability level. You need this sort of mitigation. Sort of makes. Yeah, definitely the thing that sort of spiritually makes the most sense, right? It's not anything. We don't sort of care about the rate of progress per se. We just care about, like, do you have the mitigations in time? So I feel like I don't love this like AI R&D as a thing to draw a line on, because it is kind of contiguous with all of these, just basic coding tools, or just like, you could also just ban humans doing machine learning research or something. It's sort of, it has this kind of weird flavor in some ways. And it's just it's like, if you didn't already agree that AI progress was scary, why is more AI progress scary? It's not like the final threat threat model thing, but I think that it's just like, well, pragmatically, you're just not going to have the mitigations in place if you're doing this, crazy recursive self-improvement loop. So,
right. Because when you come back and say, well, why not just hobble them any random way? Like, say that if you're doing AI research, you have to remove the E key from your keyboard, and that's going to slow them down and be really irritating.
Right.
But I mean, I guess the difference here is that if you have AI doing the work, then humans are getting further and further out of the loop of anything that's happening. It's like becoming more and more inscrutable. There's like, I guess we expect that that's the thing that's going to lead to the very rapid improvement in the capabilities. And it's something that like slows it down the more it would have been sped up. It has like at least a nice property to it.
Yeah. Yeah, I do think I just in general prefer things that are like, you have to do this mitigation rather than just like slow down.
I guess,
but yeah.
I mean, people point out, I guess that gives them the incentive to fix the problem in as much as you've specified it properly, because then they'll be able to go ahead. Whereas if you just ban it and say it's always going to be banned, then there's no such incentive is made.
Yeah, and it's like a thing that a broader group of people can get on board with. It gives you some free lunch with respect to if people disagree about what capabilities you'll have when, someone who might object to the thing that just slows you down might not object to the, like, if you hit this level, you need to do this mitigation. So sort of, can be strictly more appealing and is sort of strictly more reasonable in some ways. Yeah.
Yeah. I wonder if it's even if it's a bad idea, it's the kind of regulation that we might get in a crisis.
Right.
If you do kick off a recursive self-improvement loop and that quickly leads to an AI going off the rails and causing a bunch of damage, and then you loop in politicians and they're like, you were doing what? You took all of your humans out and just had the AI doing all the work. Like, obviously we have to ban that. I guess, I mean, that probably would be better than nothing. But I guess that could end up being the sort of naive regulation that perhaps helps, but is substantially suboptimal relative to other more sophisticated things.
Yeah. I mean, one, way that being like, just slow down or just pause or something can backfire is we would like to save all our pausing juice to the bit at which you can get the most safety progress out of your models before things are really dangerous.
Last minute, basically.
Yeah. And if people are like, it's like, oh, we paused and then everything was fine, and everyone's fed up with this and this is stupid, and let's just go ahead now. And now the computers, accelerated more, and we're going to go through this. You really want to go through that part of the transition as slowly as possible. So if there is some so
any constraints you place on yourself earlier is just creating more like latent capability to very rapidly speed up later.
Yeah, that's like one model. I don't think this is totally right. I just think people seem to sometimes miss this fact. Or I think it's like more salient the more you're thinking about like a lot of the important safety work will be done by the AI researchers at the point just before they are catastrophically risky.
Okay, new topic. Is open weighting models in general good or bad from your point of view?
Yeah, this is something I've changed my mind on a fair amount, I think. It's maybe also a bit related to being in the lower assurance world. Originally I was like, well, this seems very dangerous. Like, if the problem is that either that these things can be misused or that they can be dangerous even without a human trying to misuse them. It seems like you don't want them to be everywhere and not be able to be like, actually, this is a bad idea. Let's undo that. Like, it's like an irreversible action, and it opens up a lot more surface area for things to go wrong. If you think that it's that at least for some of the threat models, it isn't there might be a big offense-defense imbalance. So I think if you're trying to keep the risk very low, really feels like you can't open source anything that capable, because, even, again, like current models, it seems hard to rule out that with other advancements in scaffolding or fine-tuning or something, it would then become quite easy to make this model into something very dangerous. I think, I've shifted my perspective generally on how good it is to sort of like keep everything inside the labs, and differentially, would you rather yeah, sort of similar to the thing about, would you rather just the labs know about what capabilities are coming, or would you rather that everyone knows? Would you? I think in practice, the open source models have been used to do a bunch of really good safety work, and this has been important and good. And having a more healthy, independent, outside of companies sort of field of research and things seems good, both for the object level safety progress you made and for policymakers having some independent people they can ask who actually understand what's going on and are able to do experiments and things. I think also in general, I have become more skeptical of some kind of lab exceptionalism. I think a lot of the companies have this sort of we're the only responsible ones. We'll just, keep everything to ourselves, and the government will be too slow to notice, and everyone else is irresponsible. And I just think it becomes less plausible the more independent labs are saying this, and the less they actually respond to how responsible are the other actors. And just if you trust the labs, the companies less, you want less of that. And I think it's also it's one of those things that's everyone always thinks that you're the exception, and it's fine, but we'll just actually be good and actually be responsible. We don't need oversight. And I was the sunlight is the best disinfectant. People really oversight is really important, and security mindset and secrecy and locking things down can be bad. And I think there's more I can say about that.
Yeah. Okay, so seems like there's a reasonable amount to unpack there. I mean, I guess the basic reason I've heard for why actually open sourcing has been better than perhaps people like me feared a few years ago is it's been an absolute boon for alignment and safety research, because it means external people don't have to actually go work at the labs. They can do things independently, which is really useful for all of the reasons that we've talked about, if they have access to basically frontier models outside of the companies. And I guess, so separately from that, it sounds like you're saying that the companies having a very secrecy focused mindset, wanting to hold all of the information about the models within themselves, that's a dangerous mentality. And maybe it's actually helpful to have the model, the way it's opened and things being used all over the place, so that people can see for themselves the chain of thought, for example, modify the models and see what is possible if they're improved, things that wouldn't be possible if you only accessed it through an API that's highly limited.
Right. I think, there's maybe even also a point about maybe you just think some of the companies are bad actors, or there are people at them who would be bad actors, and you would prefer that the rest of the world also has access to the tech. But I think that the main thing is this slightly less specific to open weight question, and more some kind of general position on lab transparency and versus sort of security and locked downness.
Yeah, can you elaborate on that a bit?
Yeah, so I think one of my side interests is history of nuclear weapons and this kind of thing. And I think there are a bunch of examples there and in other places of secrecy and personnel restrictions and things being used to silence people who had safety concerns or ethical concerns, or were too busybodies or interfering. So both compartmentalization, so that fewer people just sort of knew about a thing and could complain it, and then trying to jail or otherwise get rid of or exclude individual people who had too many ethical concerns, basically, in particular Zillard. And I think we actually have seen this specifically being used in the AI case already, and that I believe when Leopold was fired from OpenAI, there was some claim that this was about having leaked confidential information, which I I mean, I don't know the details here, but it's very plausible to me that's like, yeah, basically everyone at these companies is doing a bunch of stuff that's like technically leaking. And if you want to get rid of someone, you can like go through all their documents and like find something that they
Sure,
did.
yeah.
Or that in general, it's like a reason to, keep people out of things. Or like, compartmentalization. Like, let's keep, this person is going to be annoying about the thing. Let's keep them out of it. And I think like, doing the Trinity test when they had the concern about might it be possible that to ignite the atmosphere, like there was basically no sort of civilian oversight of that, downstream of this being a very secret project overall and not, sort of not much government or congressional oversight. Just, meant that just the people who made this decision were the people who...
It's just a bunch of scientists and engineers who happen to be working on it.
Yeah, and military. Yeah, I mean, military. I think a lot of trying to get the scientists to shut up if they're being too annoying about stuff, and like, people who are very invested in that particular project. Like, even people who would have otherwise been relatively sort of pacifist or not super excited about weapons. Like once it's the thing that you've been working on for ages, it's really hard to be like, maybe this isn't
Maybe we should
good.
just stop completely.
Yeah, right. I think there's a bunch more anecdotes, from that history that are relevant to current AI stuff. But yeah, I think labs having, I think just like companies that are developing AI seem like particularly bad decision makers in some sense here because they have such conflicts of interest. So centralizing all of the like information power within them seems maybe a bad idea.
Okay, so downsides of them having a secrecy mindset. So the obvious benefits are, that dangerous information doesn't leak out to other groups. But downsides would be if you start siloing information within the company, then an even smaller number of people might have a sense of the general picture of what the frontier models are able to do. If they're very cautious about letting anyone outside the organization know, then it makes it harder for governance to occur, makes it harder for people to, like broader society to appreciate if risks are reaching a level that they wouldn't regard as acceptable. Right. It means that there's just like basically less oversight from anyone else.
Yeah, which maybe means like, we missed the opportunity to react to a safety incident that was, should have been a warning of like, oh, we actually, we sort of like caught the model scheming or trying to, do something bad. And instead of being like, whoa, everyone should take this really seriously and we should freak out and we should stop this kind of thing, it's just like, let's just train it not to do this, not tell anyone about it.
Yeah, right. You're saying like something could go wrong internally, but they might say, oh, it's too dangerous to let anyone know that this even happened. So it gives them a pretense for sweeping it under the carpet. Yeah. I guess you're saying, even more problematically, it allows you to just clean house to remove anyone who doesn't support the current project. If you're saying, well, anyone who's ever told anyone about what's going on in this in the company, even if everyone is doing so, then you can just fire people basically arbitrarily on that grounds. Yeah, you mentioned Leopold, I think. So that's Leopold Aschenbrenner, who I think his crime was, I think, telling people that internal information security within the company was not sufficient to stop the Chinese from stealing the model, or like that was his big hobby horse, which everyone agrees with more or less, and everyone is kind of troubled by. But I guess maybe he was making too much trouble over that, and potentially bringing more regulatory scrutiny to the company.
Right. Again, I don't know exactly what happened in this particular case, but it, I'd be very surprised if this pattern doesn't show up.
Yeah. Yeah, do you want to give any details of a particular case that occurred during the nuclear process? I guess you mentioned Szilard, who was, I think, one of the first people to twig that a nuclear weapon might be possible, and he wrote to various people to say it's really important that America do this before the Nazis.
Right. Yeah. So I'm a Szilard fan. It's like a random thing. I'm just like, wow, this is like a historical figure who it feels like is thinking about so many of the same things that we're thinking about in kind of similar ways. So I think he was very good in terms of like scope sensitivity. He was actually thinking about like, what are the most important things happening in the world? And this is, I think also some reason for being somewhat more optimistic about the ability to forecast technological progress and world events and things. And maybe some evidence that the reason why most people are bad at it is that they're not actually trying. So he, foresaw nuclear weapons in early 1930s. He was like, if you can make here's how you would theoretically make a chain reaction if you can find a reaction that is started by neutrons and produces more neutrons. And then was like, yeah, I should keep this secret. Because it seems, bad if everyone was doing it, and bad if the Nazis got it. And yeah, he also sort of forecast. He was like, "Oh yeah, I'll move to America like 1 year before the war," and he did in fact move to America 1 year before the war. It's like, yeah, okay, if you're actually trying, like maybe just geopolitical events were kind of obvious, and it's like, oh yeah, you might use this for powering ships or submarines, and actually thinking through the implications of technology seemed quite possible. But yeah, so he then. With Einstein wrote the letter to the US government that, sort of kicked the bomb project in the US into action. And that was originally, because the original justification was like, we don't want the Nazis to have a nuclear monopoly. That sort of like seems like a very reasonable justification, and that seems very bad. But during the course of the project, it migrated, from that to actually we're going to just use it to shorten the war by bombing the Japanese, and then now it's like arms race with the Soviet Union. And I think very few of the people actually left the project after that momentum. Like Joseph Rotblat was one person.
Yes. So at some point it became clear that the Nazis weren't working on this weapon, and I guess eventually then they were defeated. And that then obviated the explanation that most of these people had been given for being involved in the project at all, which was to be the Nazis. Yeah. But you're saying basically 99% of them get stuck around with a new explanation that they were giving.
Right. Like there were multiple people who sort of said like, well, this is a terrible thing, and I, wouldn't want to work on it. But, in this particular case of like, not, only the Nazis having a bomb, that would be really bad. So, I'll work on it in this special circumstance. Then it's like, oh yeah, that isn't actually true anymore. And people are like, well, I'm here now. It's go, there's like investment, and these things get their own momentum. And I think there are, I feel like I see parallels in AI in terms of people give reasons for why it's important for them to be first or push ahead or something, and they're like, oh, we're the most safe, or like this other competitor is, doing this thing, and like their actions don't change as those other facts about the situation change. I mean, one thing is also like that very little effort, proportionally very small amount of effort went into actually trying to figure out if the Nazis did have a nuclear program. There was basically no American espionage. I think there was some British espionage, and the Americans maybe didn't even were on top of like actually what the British had learned about this. So, again, if they were actually trying to like, let's make sure we avoid Nazi nuclear monopoly, you would have been doing much more like, okay, where are the Nazis at? Is this actually a risk? Again, another example of Szilard being much better at forecasting the technological stuff. He was just like, yeah, the Soviets will have the bomb really soon. What are you talking about? And Groves was like, oh, there's no uranium in Russia. And it's like, what? Like that's like there's like the ores will be slightly lower grade. There's no way there's no uranium in the whole of Russia. You know how big Russia is, like and it's like oh, our brilliant American boys, no one will match that. It's like no, this is just like not actually that hard. And also they had
they just copy. Yeah, they had
like there was all this
about
secrecy.
10% of the people there were Russian spies.
Well, only a few, 1%, but like they had there was various information that they actually had like before the Americans did because of spies in the British Foreign Office, I think. So it's like, there's all this stuff about secrecy and locking down and then there was also just that secrecy was like completely useless. And people were just not planning for this arms. But Szilard was like, okay, the thing that is really important now is there's going to be a nuclear arms race between the US and Soviet Union that is going to be potentially world ending, and we need to figure out how to try and make that less of the case and how we can like reduce tensions with the Russians now. And other people were like, whatever, no, they'll never get it. Just like, I don't really know.
It's hard to fathom.
And the amount of effort that went into things like thinking about alternatives to bombing Hiroshima, to actually destroying a city. Could you explode the bomb in the air or on an unpopulated area to like demonstrate the capability or something? And just like, it was like, people like discussed it a bit over lunch on the day that they were making this decision, but there's like so little effort put into some of the key decisions, and similarly with potential sort of world governance of the weapons, the like Atchison-Lilienthal plan of with sort of like inspections and things that like the people who were working on it sort of were conflict of interest with, they had various industrial things that would benefit from nuclear arms race. If I remember correctly, it was Lilienthal. And then, again, just generally it was very like half-hearted effort, and was kind of like, they just wanted to do something so that they could have been like, we offered something, the Russians said no. But, maybe if there had like, it feels like you sort of have less evidence than you might think that something like that would have been completely infeasible, because there was very little effort into sort of mechanism design of how you could have transparency about this in a way that was less unpalatable to the Soviets, who didn't want a bunch of stuff about how badly things were going for them in general to be known. So, I don't know, some kind of just actually trying at the most important things seems like it would have been pretty leveraged if you'd had some detailed alternative proposal that was well thought through.
Yeah. I guess
plausibly.
The generalized thing to keep your eyes out for is if people say, I don't want to do this, but I have to do it because of X.
Yeah.
But they show almost no interest in finding out with confidence whether X is true or not.
Right.
And they don't stay up to date on whether it's true or not. They also maybe show no interest in changing X, taking steps, things that would fix X and make their actions no longer required. And also when X stops being true, they don't change their actions.
Right.
Then these are kind of giveaways that maybe X isn't the real reason.
Right. Well,
and I think we may see a fair bit of that at the moment.
Right. The thing has acquired its own momentum or whatever. And there's the sort of, like when Dillard was trying to get Truman's incoming Secretary of War, I think, to, trying to convince him that bombing Japan was a bad idea. He was like, well, what are we going to tell Congress we spent all that money on if we don't do anything with it? It's like, oh, God.
Yeah. It's a little bit embarrassing to kill that many people in order to just have a better answer at a committee hearing.
Yeah. But that's what things get decided on.
Yeah.
One of the reasons I think pre-scalar evals would be good.
Okay, so that's saying that's a reason why we should figure out whether a model is safe before we spend all the money training it, because once you have it, the temptation to pull, or once you've spent all the money, what are you going to tell the board?
Right, the investors, yep. Oh, I thought of another analogy to the nuclear stuff we're talking about China, which is maybe something that was important was the compliance of kind of individual scientists in different countries. So one thing is, I think this is pretty unclear, but there's maybe like hints that some of why the German bomb program didn't go very far was partially that the scientists were not very excited about, nuclear armed Nazis.
I see. So you say, I think, has it been suggested that they deliberately made bad strategic decisions, basically, because they were trying to make the probability of success lower?
Right.
Just to tie this back to the open weighting, open source question, I mean, if we just start open weighting all the best models, aren't we kind of baked? I mean, it makes any governance virtually impossible. It means that any misuse is going to happen very, very quickly. What's the upside story? I guess it means that you get better warnings maybe early, so it could lead to if there's people who are saying, we don't really have to worry about the misuse, and then something is open weighted and then it's immediately misused for some catastrophe or some like horrific crime, then maybe that could lead to improvements in governance.
Yeah, I mean, I don't advocate doing things to cause horrific crimes.
Right. Yeah. I guess we're doing everything we can to stop that. But I suppose if we fail and people who are against any kind of governance succeed, then I suppose a possible upside of that is that we all get to find out who was right, sooner.
Yeah. I mean, yeah, I think the case for, certain types of transparency and openness is much stronger than the case for specifically open sourcing weights. But I do think the open sourcing thus far feels pretty clearly net positive just because of the impact on safety research. I do think you would have thought that it ought to be harder to argue that we're in an arms race if people are open sourcing the models, but somehow this doesn't seem to have stopped anyone.
Or never let common sense get in the way of the narrative that you would like to spin for your commercial interest.
Yeah.
So just to clarify, you're talking about the release of DeepSeek R1, which this super weapon that the Chinese developed and then immediately gave to us for free in exchange for nothing. Yeah, it really shows that we're in a very intense arms race with the Chinese to, I guess, give one another our greatest technology. It is extraordinary that did not preclude the arms race narrative. I guess you could say, well, maybe this shows that they will be able to make something in future that they won't share with us. But you'd really think literally giving away your weapons designs would be definitely an olive branch to your enemy.
Right. Yeah, you would have thought. I think, basically what you were saying about, like, if there are incidents, they happen in public rather than just inside the lab. And especially if it's sort of, you have to have open sourced the weights before you're allowed to scale up by this much, that'll be one thing you get around, like the lab can be doing this crazy thing internally that no one has any idea of, like at least outside you'd be able to demonstrate like, oh, this model is pretty close to being able to do this thing. Maybe we shouldn't let them build even bigger ones. And I think also, like, unless you have very good security, the story of how you're okay sort of doesn't depend on not open sourcing. Like, it seems like if you have a sufficiently, powerful model, then like a bunch of people are probably going to be interested in it. And companies currently don't have the sort of security that would keep out like state actors or like the best
private actors.
And then so your theory of victory has to be something about like, well, we'll use our good models for something good, and that will prevent some harm from these other models. So I think most of those stories actually just also work if there's open models everywhere, because it's more about like, well, more of the people who control more of the compute want models to be doing these kinds of things than want models to be doing these nefarious kinds of things. And like, it does feel like sort of either you have to be extremely locked down and it is just like, there won't be any like bad actors, or you're making some argument about, we can use these models defensively in some way.
So the story there is, well, part of it is the security at these companies is not so strong that the models are not going to leak to various nefarious actors.
Right.
Anyway, we should at least be honest about it, and they may as well open weight it, and then a whole bunch of like nice people who didn't even have to steal it might be able to use it.
Right. It's like, maybe they're currently, open weight from the perspective of North Korea or whatever. It's like there are no something that I sometimes say, like there are no closed weight models. Like no one has that good security.
That is very interesting. Yeah, I mean, I think most people know, but maybe not everyone, that North Korea is actually very strong on offensive cyber capabilities. It's not only China that might be able to steal it. I guess you don't think of North Korea as a technological powerhouse, but on this one thing of stealing information from people, they are quite good.
Right.
So, you've been using this analogy between AGI and nuclear weapons. I guess it's a comparison that people have definitely drawn a lot over the years, and people have like both reasons to think that it's interesting and reasons to think that it's misleading. Do you want to give a take on like what you think the important disanalogies are? Like in what ways is the situation different today versus with Stellard and so on?
Yeah, I mean, obviously there are a huge number of disanalogies. Like AI is just much more general purpose. I do think it maybe ended up being a bit less disanalogous than we might have worried. Like I think, 10 years ago, maybe people were worried that you could build AI. It would just be the, coming up with the right algorithm and then you could do it on your laptop. And that would have been much harder to control. Like in some ways, the story of nuclear proliferation is quite successful in that it, it was limited. It's not like, everyone has these.
Yeah.
And that's partly because the detection is relatively easy. You can tell when someone is doing this because you need big facilities, and it's also like you need to have like industrial capacity, and I think AI has ended up being more like that than we might have feared, and that you just like need a lot of chips and you need a lot of energy in a big data center, and it's not like anyone could be doing it in their basement at any time. I think maybe like an important strategic disanalogy is like, so nuclear by default advantages countries that have like a large industrial base because it's so industrially intensive, right? It sort of like differentially elevates like big developed states against like terrorist groups and rogue nations and things, and it's like not very sort of stealable. It's like the amount of nuclear capacity you have is pretty proportional to your existing power. Whereas I think there's a bunch of ways that AI is more analogous to bio in that it's sort of more in the direction of destabilizing, or maybe favors more like smaller actors more, in that maybe in some of the kind of threat models, it doesn't matter that much how much resources you start with, because the thing is relatively, it's relatively easy to steal. It was like nuclear material is much harder to steal because it's just like stuff that's there and it's big. But this is like software, this is data. It can leak relatively easily. And if you're talking about like autonomous AI, it's like it can make copies of itself and spread itself around. So it's not like the sort of amount that you can deliver is proportional to like the amount that you had in your warehouse. It's more like a bioweapon where it's like it spreads itself. Yeah. And it's less tied to like the work that you had to do at the start, and it's more easily leaked, and it's more maybe just like this is the sort of thing that could be used as an agent of chaos more. So I think this is maybe I'd like more people to sort of be aware of this argument, because I think it's a reason that like big states like the US and China should be concerned about rapid AI progress, because it just like is a sort of destabilizing thing, and they're they're currently doing well and sort of on top, and this is making something that's sort of can suddenly spread out of control and can be stolen by a terrorist group or something is just like actually really not in your interests.
I see. So the way that it's in the selfish interest of the US is that, well, it maybe has a lead in the relevant technology right now. It seems like it's going to cost at least billions of dollars probably to train the first frontier model that is really useful as a weapon, or useful offensively, or at least like useful for maintaining industrial dominance over other countries. So that could allow it to kind of lock in its advantage. The downside for the US is that if that period passes and it becomes a whole lot cheaper, and also these models are disseminated quite broadly and they're possible to steal both by states, but by also private actors potentially, because they're just all over the place, then that's actually a huge weakening of the US's strategic position, of its security position,
right?
Because in the same way that dissemination of bioweapons would be, because it wasn't the case that only the US and China and Russia could have designed bioweapons. Actually, like dozens of countries probably could have, and they would be absolutely devastating. In some ways, they would provide a stronger deterrent and would be even scarier than having nuclear weapons, which is one reason why the US was very keen to discourage their creation and to create a taboo on them, because it would ensure that the previous generation of weapons of mass destruction, nuclear weapons, would remain the dominant ones that countries cared about, which was something that the US had an oligopoly on.
Right. Yeah.
So if we get to the point where basically nuclear weapons and bioweapons are now obsolete, and actually it's AI that is the key thing that can cause damage if you want it to, and this is disseminated very broadly to all many different kinds of actors, then the US government is now basically just a weaker player in the world as a whole. And the Chinese government is also just a weaker player as a whole.
Yeah. I think, there's maybe some analogy with like some of the, NSA exploits that got leaked and then started being used by Russian hackers against US citizens or whatever. It's like, the version of a bioweapon where it's like, oh, you're going to develop this super advanced bioweapon. And also, by the way, it can be stolen if someone hacks your computer. It's like, sorry, and this is good for us. Why?
Especially because we're already winning.
Yeah. Right.
Why do we want to create this enormous vulnerability to our position? Yeah. So you were just referring to the NSA. I guess one of the cyber offensive organizations within the US, they had a whole bunch of tools, cutting edge tools for breaking into people's computers and phones and so on, and stealing information from them, which I think they literally accidentally posted publicly on the internet. Or there was at least like one leak of that basic type. But maybe you're saying one way or another, the Russians got access to these tools that they had designed, which is the kind of thing you might expect because the Russians are also very good at this. And then those weapons could just be immediately turned back on the United States. So perhaps it was, even if it was like narrowly in the short term good for the NSA to have those those weapons, maybe it would have been best if they for the United States more broadly if they'd never been created.
Right. Yeah. So I just think this is a pretty good argument that the sort of arms race framing doesn't really make sense in terms of like US and China national interest. I mean, it's like obviously AI is not just a weapon and has like a bunch of other benefits and things as well. But I think from this sort of if you're thinking about it in this arms race mindset, then I think there is this pretty good argument that what you want is less of it.
I see. Yeah. Or that's what the national security folks should want. Or at least if they could come up with an agreement between themselves and China, and then maybe a few other major players, to not develop this thing that is destabilizing and that actually weakens their relative power, then that would be great. But I guess there's almost no discussion of that possibility.
Right.
I mean, I think one reason for that is maybe that they are anticipating that they will be the first people to get to this incredibly powerful thing, and then they'll be able to stop other people from developing it. I guess maybe that isn't always said out loud because it sounds a little bit hostile, but basically they're imagining we'll rush to this technology and then basically try to become a permanent hegemon who prevents anyone else from designing stuff that would be destabilizing. I guess maybe it would be good if they were a bit more explicit about that, and then people could weigh in on whether they think that's a good approach or not.
Yeah. And it does feel a bit like one of the things where it's like, well, you could also work more directly on like, what would we do to cope with like scary AI, and that it's not clear that the response is immediately like, yes, build your scary AI as well. Or just like the stories I've heard for like how you use your super capable model that you built to keep the world safe are just like not that compelling. I feel like that, this is a thing I would love people to be thinking about more and thinking about more explicitly. Like all of the, things where it's like, the lab theory of impact is like, we're going to build this thing first and then we're going to be responsible for it. It's like, okay, what exactly are you going to do with it? And like what capabilities do you need for that and these kinds of things. Yeah.
I mean, almost all of these stories involve at some point blocking other people from designing their own versions of it. I guess maybe one reason that isn't advertised is that just it does sound like quite hostile. It's hard to sell that to people ahead of time.
Yeah, but it's also like there's a bunch of things that we could do that would achieve that don't require building super scary AI. Like just like have fewer chips
or have compute governance.
There's a bunch of compute governance or like I don't know, just. I don't know, gathering up a bunch of the relevant scientists and putting them on working on something else. It's just like it just feels like there's this response of like, oh, in that case, we've got to build a bigger one. It's like, okay, but what if you actually started from the thing that you're trying to prevent? Because like, it's sort of like, okay, nations are already pretty great at like threatening each other with, mutual destruction. It's like not having a more destructive threat really doesn't help you very much, like above destroy, most nations are basically like destroying a few cities. That's like as bad as the end of the, they won't prioritize like that differently than the end of the world. So just like escalating your maximum threat doesn't seem that helpful. So it's got to be some kind of defensive tech thing. And so it's like, okay, maybe we should just think directly about what that is. And maybe there are more efficient ways to make progress on that.
All right, let's switch on to something a little bit different. There's lots of different organizations in this general tapestry. I guess, there's METR, there's the companies, there's government agencies like the ACs. I guess there's other independent non-profits, I guess like Apollo, I guess like AI AI company watch. I don't know. I can't remember all of them.
Yeah.
What would you say is the comparative advantage of METR in this ecosystem, and maybe what is the strengths and weaknesses of the other alternative groups that are involved in evals and and enforcing responsible scaling policies in general?
Yeah. So there's I have a bunch of stuff I could say here, but I'll start with non-profits versus governments versus companies, and in terms of sort of like who should work at each or something. So I guess we talked a bit already about like model access for research and things. Yes, I think that is one reason that people use for going to labs. I don't think that is a huge deal. So I think METR has like some disadvantage of having less info and direct access to models and things, but I do think actually
you're doing just fine.
The compute availability, labs give us free tokens. We can buy our own compute for doing our own experiments, and there are good open source models. So I think the advantages of METR are we can really just focus on the mission. We don't have any sort of other competing priorities, and I think that governments have various sort of political things that affect what mandate they have, and they've got to impress various people. Their funding is maybe they have maybe less longevity. They're more don't know whether they're going to be around in some number of years. Whereas METR is more just yep, we have fundraising. We expect to be able to keep fundraising. There's no particular reason that METR would disappear with the next administration.
Yeah.
And unlike being at labs, it's not this safety thing would be better if it made our product more useful. Or can you, this technique is helpful here. Can you please help us do this thing? Or you better do those evals quickly because otherwise it'll be blocking deploying this next model. And in that case, you're just kind of always sprinting, trying to get the evals done so that you're not either just not finished in time, or if they actually were to delay until the evals are ready, which I don't know if they would actually do. But whereas at METR, we can just be okay, what are the most important things for the field overall that are just highest priority for us to work on, and basically do that without, if we're actually it's maybe not that important to do evals the specific point for the specific model, we're okay, cool, we'll just focus on something else.
So what's the weaknesses for METR?
I think it's just size, in that the sort of total amount of technical talent is obviously much lower than at a huge company, which has a bunch of people who are just doing capability stuff and are super expert in their own areas. I think so in some senses, there's less mentorship and more just more sort of normal sort of startup property of you get thrown in and you grow because you're given a bunch of responsibility and you have to grow to live up to it, as opposed to you're this cog in this big machine, you're being coached and you're incrementally doing more moving up the ranks or something
in a way that's very organized and predictable.
Right. Yeah. So I think for people who very much want a quiet life, very predictable and want to sort of be told what to do more, it's not a great fit. There's a few patches of our work that are more like this, but more of it is more kind of fast moving, and just being a smaller organization I think is helpful for being able to pivot more rapidly, and just a bunch of things are changing all the time and progress is fast, so I think that's pretty useful. And it's easier for us to prototype things that we want the company to do that would be harder to get them to prototype internally. So we've been thinking about doing a control setup and control evals for our own usage of the models, where we do things replacing all the models we're using with one that's been prompted to try and screw us over or something, and then see how this goes. It's just way more likely that METR could do that than DMine is going to do that or something. But I think similarly on the good at sort of exploring or moving fast, compared to working with governments, it's sort of lower stakes for labs to work with us. It's less of a sort of, I don't know, just has less of this like, oh, you need all the GovRel people to sign off and the it has legal stakes and whatever, and it's less like formal and more like, oh, I guess we can just like do some research together. Yeah. Wait, but I was supposed to be talking about disadvantages of METR.
Well, I guess, I mean, the usual thing with nonprofits is that it's harder to scale really rapidly. It's, even if you're succeeding, that doesn't necessarily translate into like much greater fundraising that would allow you to do your stuff, 10 times or 100 times as much. I guess that might be one issue among others.
Yeah. I think it's more just like we've found it harder to hire because we're not paying as much as the labs. Like I think sometimes people think we pay like normal nonprofit salaries. That's definitely not the case. Like we pay approximately matching cash compensation that people would get at companies, at AI companies, just like the equity is impact equity, imaginary impact equity. So it feels like that's been the limit to growth, is like hiring technical staff. It hasn't actually been fundraising. Like I think if that started to become a bottleneck, we could do more like charging for our services, and I think could push more on moving things like the AI safety fund along. So this is like like a bunch of labs could put a bunch of money into a pot run by the FMF, and then that could like be granted to sort of third-party eval orgs or other non-profit safety, independent safety things. So it's like it's good because it scales with the capacity of the labs. Like the labs are paying for it, but it doesn't have this direct coupling with like making them happy. Right. Like there are I think multiple instances of financial auditors signing off on various books that were extremely dicey because I think famously with Enron or whatever, Arthur Andersen, like Enron was
because they want to keep the business.
Yeah, because they also had they had the auditing and they had a consulting arm, and it just like was some very large fraction of their overall revenue. So it just like would have been extremely bad for Arthur Andersen as a company to not just give Enron what they wanted. So you want to avoid that kind of setup. But I do think if you have something where there's like an industry group and, to be a member, you have to pay into this pot and then that's distributed to evaluators. But there isn't this specific relationship between like, will a particular lab keep working with a particular evaluator if that evaluator gives them an unfavorable rating? Right.
What's the FMF?
Frontier Model Forum.
Okay.
So this is like this is a 501c something else. It's like sort of point of it is a carve out from antitrust, where companies can talk to each other about things like sort of like safety and incident reporting and RSP agreements and whatever without being subject to the usual antitrust concerns. But it's also sort of makes sense as a hub to coordinate other things.
So do we currently have an arrangement where there's some like pooling of funds and then I guess like auditors are assigned to companies somewhat, whether they like it or not, so that there isn't this strong incentive for them to just get the answer that they want to hear?
No, there is a pot of money that labs have contributed to that's sort of set up by the FMF that has like $10 million, I think. But I think this kind of thing seems pretty feasible because like this is just pocket change for the labs. Like it's really not that much money for them. So the money side I think is fine. So it's back to the whole point of this is like METR, I don't know, has generally been more bottlenecked on talent than on fundraising.
Than money. But it sounded like you were saying, well, one challenge with attracting the right talent is that you're not able to pay them equity in the way that the companies can, which I guess, given how the valuation of these companies has exploded, might be a big factor in people's choices, or that the dollar signs can be very large in people's eyes.
Right.
So I guess like money maybe is an issue, that you need to pay people more extra cash, and if you just had absolutely unlimited financing, maybe you would pay people more.
Yeah, I mean, obviously these things trade off. I think, just when you're saying like, what are you bottlenecked on? It's sort of like, what is do you think marginal people should think is the right thing to contribute to or something? I'm like, like more, more funding would help like spend less executive time on fundraising, and we could do things like pay higher salaries that would allow us to attract more talent. But it seems like we're probably at the point where there's not that many people who like, oh, if we just paid them a bit more, they would have, it's like, oh, well, we could like 10x like what we were paying people, and then maybe we'd be competitive with lab equity or something.
Okay.
But or maybe not quite that high, but probably for some early, it's sort of almost in that region. So it's like, okay, well, that would be a lot of fundraising, or like a few marginal people could be like, oh,
could
I hear
accept a merely very high salary in order to save the world.
Right, right. It does feel. I'm like, why? Like 80,000 hours. How many people have you coached? Why can we not hire a senior software engineer? Not even an ML engineer, just a software engineer or like DevOps. I'm like, where is everyone?
Interesting. Do you want to go through the kind of roles that it will be useful for people to potentially apply for if they're suitable?
Yeah. So we have like senior research engineer / research scientist roles. That's, just the kind of like normal senior ML role. Sort of need have some combination of research and research engineering skills. So it can be sort of anywhere on this continuum. You just need the sum to be good enough. And then, also just senior software engineer and senior DevOps engineer. And also, I don't know what exactly is going to be up on our website at the time this podcast goes live, but currently maybe looking for like head of operations or operations lead. And basically sort of always looking for senior technical talent.
Yeah. I guess for technical people who are listening and still listening at this stage of the interview, I guess this conversation hasn't been maximally orientated at you because you're a relatively small audience. And if you would like to know more about like what METR does and its most impressive work, you should go out and check at the website metr.org, where you can read the full research reports and see if you think that you're impressed and it's something you would like to be involved with. Yep,
and apply, chat with us, or you can if you want a taste of some of the activities, you can. I think we're probably still looking for baseliners, so you can compete with the models on the ML tasks, and we've been using these as like work tests for the humans as well as for the models. So
so just to be clear, baseliners are people who you use to measure how difficult the tasks that you're giving to the AI are.
Right.
So you're like establishing the baseline.
Right. Yeah.
I guess, another reason why you might find it a little bit challenging to compete with the companies is that they have, like huge recruitment teams that are specialized in corporate recruitment and recruiting people from in exactly the tech industry. I'm sure they know, all of the things you do, take people out to dinner, give them exploding offers, really put the hard word on them about how important this is, maybe trash talk everyone else. And I guess those are things that as a smaller nonprofit, perhaps a little bit friendly and a little bit less corporate, you're less inclined to do perhaps.
Yes, we have in fact encountered all of the things that you named. It is a bit unfortunate. There have been, I think we just can't compete with the sort of level of recruiting intensity, really. And I just also really, I don't know, maybe this is just a personal flaw, but I'm just like, I just really don't want to do that. It just feels like such a waste of everyone's time to be really sort of, there's something which makes sense, which is like everyone should explain like who should work at their company and why it might be good and like what are the advantages, and then people should like talk a bunch to each other and decide. But there's something that feels like it's going on at the moment where it's like, people spend like a ton of effort and are like trash talking each other and trying to compete on, I don't know, it just kind of feels like a waste of everyone's time and is unhelpful. So I wish people just made decisions in a different way that was less affected by like who took you out for dinner more times or something.
Yeah. Some of those things are a bit disreputable. I think exploding offers, probably no one would say that is the optimal way of allocating people across different organizations. Right. These are things where you say you got to join within 24 hours or we're going to reject you. Other things, I suppose, like talking to people at great length and really pitching them very strongly on the value of the work, I guess it seems like it's fair play. But you also really want to be doing your research, right? So it could be hard for people to carve out time to compete with people on the level of aggression that a for-profit company can potentially offer.
Yep. Yeah. And we've got there's sort of had people who I think of as relatively senior being like, oh, well, I want more senior mentorship, so I'm going to go to this company. It's like, no, you were supposed to be the senior mentorship. Like there was a bit of a like bootstrapping thing here. But I think also there is we actually have some like staff who are sort of young in age, but like are sort of senior in ability level and just like are not kind of famous in some ways. And I think hopefully this is getting better over time as we publish more stuff.
Are there any other organizations or work that you would like to see exist that doesn't exist, or any things that people might think that you're doing that in fact you're not actually able to do that other people need to take on?
Oh man, I have a very long list here. One thing that people seem to get confused about is the extent to which we're really sort of like serving as the auditor for all these companies, and we're like not really doing that. Like that is, we're kind of trying to prototype these oversight arrangements and be like, how can we, what arrangements sort of work technically, and like, maybe if no one shows up and it really seems like crunch time, we'll just try and scale and do it ourselves. But we were sort of imagining that someone else would do the more like formalized version of this, and we would continue to do the sort of like research exploratory version. Like, maybe that's the ACs, but if the ACs get removed, then someone else needs to do that. Yeah.
I mean, who would that be? So the AI safety/security institutes, they're government organizations. This would obviously be their natural role, I suppose, auditing all of these frontier models to make sure that they're not able to do things that the government regards as incredibly dangerous and illegal. If they don't do it, who would do this?
Yeah, I think there are a bunch of sort of more specialized organizations that maybe make more sense to do at least some of this, like Patton Labs for cyber. I don't know, there's just like organizations who have more specialization compared to METR with a sort of like customer facing delivery, where we're kind of very like, but is it actually, how much is this actually improving safety? Like, are we learning stuff? Are we de-risking things? Like, is more our focus? I think we might sort of expand more and have a more like, sort of evaluations as a service arm, but like that's not something where it's like, oh yeah, we've got it covered, like no one else should bother. It's like, no, please, come and do that. And we've only been doing dangerous capability evaluations thus far, like with just we've kind of been thinking about alignment and control a bunch the whole time, and this has been in some of the RSPs and stuff to some extent, at least been in our thinking about it, but we're only just starting some of that now. I mean, yeah, I think Apollo is doing good stuff and interesting stuff. One thing is, I think we're imagining being more like the, trying to focus on doing good science and being sort of neutral experts, and less on like advocacy and really holding labs to account or political campaigning or any of those things. So there's things that we sort of very much like don't have covered. We're much more like technical advisors, and someone might come to us and be like, is this bill good? Like, would this bill actually reduce risk? And like that is the sort of thing we'd be very, very happy to answer a bunch of questions about. But we're doing, we're not doing like, oh, how can we like raise awareness of raise awareness of the fact that this lab isn't doing this thing they said they would or something. It's like not a thing that we're on top of. So we're not sort of providing accountability for the kind of companies in general. We're much more just like trying to figure out how do you tell if the models are about to kill you.
Right. Yeah. I guess so. Fundamentally, you're a research institute. That's your core culture.
Yeah.
And you're trying to figure out how to measure things that have never been measured before. Right. How to quantify things that have never been quantified before about these models, which is an enormous train because so little is known and understood. Right. I guess there's room for pressure groups. There's room for policy advocacy. I guess there's room for the like for-profit auditing thing that can scale enormously and is able to implement, in a practical way, the kinds of discoveries that you might have been making a year or two before. Like
one paradigm I can imagine being in is like there's someone else sort of offering these more scaled services, and METR's role is more like reviewing this for quality. There's some, does this eval actually provide the evidence that it's supposed to be providing, as opposed to just like running them for all the companies that want them to, like, there's just like quite a lot of models that people want evaluated. Another thing, and we're just, we just happen to be the, evals is our focus or something. I don't think that's because evals are the most important, more important than everything else. I think there's just a ton of work in the improving the mitigations and actually implementing them at companies that is not being done. I mean, it's like the unlearning thing. It just feels like there's a ton of incredibly basic things that just like no one has tried, or things like providing a filtered data set that we think that, maybe just like it would be good to remove a bunch of the stuff about scheming AI and put a bunch of stuff about humanity and AI being friends in the data set. Like, it just feels like there's sort of various dumb interventions that just would be good. I don't know, like more support for whistleblowers.
Okay, we've been going. You've been very generous. I guess we've been talking for four and something hours at this point, so we should probably try to begin to wrap things up. I feel like the conversation has maybe leaned a little bit towards the doom and gloom. Maybe I'm a little bit jet lagged. Maybe I'm leaning towards the negative this week. In terms of something a little bit more hopeful, I guess. Well, I'm curious to know what is like a METR's research agenda going forward, and maybe also it sounds like despite the fact that we're in a somewhat negative or like a somewhat challenging situation, you might say, there are a lot of different useful threads that people could pull on, and really the problem is that people are just like not taking all these like all of the low-hanging fruit that's available is not really being taken. There isn't the resources or the focus or the number of people involved. So the positive side would be that there's so much that can be done.
Yeah, it feels like we're just in some very high stakes situation where it's kind of like there is everything to play for. Yeah. It's not like, the outcome is overdetermined. It's just really like there are all these like extremely valuable things to do.
Yeah. All right. Well, let's take it bit by bit. So what are the priorities for METR over the next couple of years?
Sorry,
I should have said next couple of months. Yeah, who can plan over that kind of time horizon?
Yeah, well, next couple of months is about it's pushing it. Who knows what models will be out by then? But so we are thinking about what are the most important asks to make from companies, sort of like now, given what we know overall, and sort of, what exactly are the biggest things that we want to sort of tell the world that we think are most important on that front. And it'll probably, trying to get out of somewhat like reactive mode in terms of companies being like, please do these evals for us, and get into like, what do we think are the most important things that should be happening, and kind of like make that clear to everyone. That's one strand of things. And then another strand is moving beyond just dangerous capability evals into alignment or control evals, and maybe also communicating to people why we think, like why we're doing that, and why we think the sort of inability safety cases are not going to go that much further.
Okay. And a control eval would be figuring out, so control, we're going to do other interviews about that, but that's an approach where you say, well, maybe this model would like to screw me over, but we're going to put in place constraints on it that would mean that even if it was trying to escape, or it was trying to cause some harm, it wouldn't be able to. And so a control eval would be evaluating whether such a setup is actually functional. So I guess you might get a model that you might actually make a model that would like to do something bad, and then see whether the constraints are actually binding on it. Is that the idea?
Right. And there's and so in some sense you can think of the current like dangerous capability evaluations as like a special case of control evaluations where your control strategy is nothing. So if it's like, okay, but what if, we did some kind of monitoring, or we had, there's just like a bunch of interventions you could do that hopefully would make it harder for models to do extremely bad and scary stuff. And we can sort of see, like try some of those out and test them. And one thing I've been toying with doing, is like, so the idea of how you would evaluate a control setup is like maybe you want to red team it with someone creates a model that is just nefarious and is trying to mess with you, and then you see what it's able to achieve, or you set some threshold of like, if the model is able to set up a sort of an agent that we don't realize is running for this many days, then that, that counts as the sort of like catastrophe, and we're trying to build a control system that can prevent that, and then you test that with your team. So we could potentially do that internally. I think something we might work on a bit first is more making sure we're getting maximum use out of current models and like using them in our research to accelerate the research in general. And then like the more we do that, the more relevant the control stuff will be, because it's like, oh, could the model now be sabotaging your research or something? Like now you're using it more. And then another thing that we're working on is if you hidden chain of thought, you can't tell if the model is maybe deliberately sandbagging or messing with your evals. You can't trust the results of your evals if you can't see all the thinking that the model's doing before it answers. But maybe labs are very unwilling to share the chain of thought. We're like, okay, that seems like at the margin, the thing that would most decrease our current fear about models would be that we know that something has been run on the chain of thought that like looked for any kind of like scheming or checked if it was totally illegible or whatever. So we're like, okay, let's build a data set and some kind of classifier setup based on open source models that then a lab can run, and they can at least, they don't have to release the whole chain of thought. They could just release like the numbers and maybe a smaller number of examples that like wouldn't be enough to distill on, or like rephrased examples or something.
Yeah. Okay. So just so I understand, I mean, I really, given all that we've been talking about with the chain of thought, a really obvious thing to do would be to have a model that can actually read basically all of the chain of thought that these models is outputting and say, is there some obvious like secret code going on here? Is it producing neuralese? Is it producing this gibberish that I can't make sense of? Or is it just literally talking about scheming? I mean, that would then it definitely adds an extra constraint, an extra challenge for the model if it wants to do anything nefarious. If you've got another model basically that you do trust reading its mind all the time.
Right. Yeah. And it would just be nice to know that at least the model isn't just blatantly doing this. So I think that the two things that we would need from a lab to sort of establish this is, like one, you ran this classifier and like, you didn't find any examples. And two, you declare that there's sort of like no reason to expect that the chain of thought would look normal, but would be hiding this kind of thing. So like you haven't trained it specifically to sort of like not say this kind of thing out loud.
To obfuscate its true thoughts and its true communication.
Then you train your classifier, or maybe this is just a prompted model, but you want to look for things like, is this gobbledygook? Is it understandable? As how sort of far from reasonable English does it seem to be? And then is there any reasoning about how to do on the evals or scheming or any underhanded behavior basically? And I think a lot of the value here would not. This is not a control proposal, and you're not necessarily like trying to, you're not imagining the model that you're maybe scared of, like reasoning about this monitoring and its chain of thought and being like, oh, I have to do something that the other model won't recognize, or, I have to like suddenly do something that won't get classified. It's more just like, okay, if we're in this situation where the model is just blatantly doing this misaligned thing, it would be nice to know that. So if we assume that it's not smart enough to be doing all this reasoning about how it might be monitored sort of in the forward pass, but it can only do that in the chain of thought, then this should catch that. And that we just need to sort of make the data set diverse enough that it's, we have a decent chance of catching a bunch of things if this is going on, as opposed to like this needs to catch every single case. Because it's like question about the overall model tendency, rather than like this is trying to prevent specific occurrences.
Yeah. Is there any other low-hanging fruit you want to shout out that METR might take on, or you'd like to see other people have a go at?
Yeah, I think there's just a lot more stuff to be being done on mitigations and just improving the odds of good alignment. So I think we touched on this earlier, but sort of making the supervision signal more accurate. Like, I guess some question people might have is like, what is the story for these models becoming malicious when currently they seem like so nice and friendly and, and helpful and polite and stuff? And I think just intuitively, I think it's helpful to imagine like kind of analogous to a human who like becomes very cynical or sociopathic or something. Like you can imagine, like particularly if the model is being trained to kind of give contradictory answers to like please different users in different ways, or like to say things that humans think it's true that the model knows are false. Like it's more like, it's maybe coming off, it's like coming off as like super friendly and happy and whatever, because that's what you've been rewarding it for. But actually it should be thinking about like, okay, well, what does this guy want? Like, like what have I got to say here? Oh, right, these ignorant like humans don't understand this thing, so I better say,
better tell them what they want to hear. Yeah,
right. Like, I think that's the sort of like intuition for me for where this would come from. And I think this sort of, aligns with the, theoretical claim of like doing this kind of thinking would actually improve your score. It's like a reason why, some cynical manipulative humans can do better than genuine ones. Like,
interesting.
Because you can just like tailor. You're just directly reasoning about like, how do I like push this person's button? And
I got to tell my boss how great he is.
Yeah. So I think this is sort of like phenomenon we're already aware of, and it would be nice to. I'm just like the more, the sort of the less we can push the models into that, the better. Just have a higher chance of ending up in some basin of nice personality, and also it would be nice if we could sort of measure this and get a sense of how much is this going on, like, and how much is this training process really pushing the model to be playing the training game and trying to game things. I think there's a bunch more model organism work that would be interesting and useful to do.
I've heard people talk about model organism work, and I guess from the name I have some idea what that is, but could you elaborate a little bit?
Yeah, so it sounds like you read the alignment faking paper. So that would be an example of a model organism.
I skimmed it.
So just like, here is an actual instance of the kinds of cognition and behavior and things that we're concerned about happening in a model. So there's a bunch of ways, people could push on that and make it like more realistic, do it with smarter models, see if we can get more understanding of like, what exact kind of fine tuning, is needed to give it this information, and could we sort of like check whether it, had sufficient information to be doing this, and can it do it without reasoning it out loud, and there's a bunch of things here. Maybe one other thing that seems particularly good is actual applications of interpretability or otherwise developing more methodology for telling how useful your interpretability progress is. So I think maybe a sort of nice example of a test case for interpretability is, so in the alignment faking paper, most of the experiments are with the model with the scratch pad, where it has this hidden place to do all the reasoning, and that's where it is like, if I want to be able to keep to my values, I should do this thing. They also found that some of the time, even if you don't give it the chain of thought, and it just has to answer straight away, it also appears to behave like to fake alignment, in that it like does the thing when in the conditions where it's being overseen, and then like doesn't do it in the when it can get away with it.
Right.
But it's hard to know when you're not seeing the chain of thought. It's like, well, is that why it's doing it, or is something else going on? Like, is there a confounder there somehow, or just this is just like not what we think it is somehow. So I feel like that's just a very good test case for interp, where we're just like, can we produce evidence that what this model is doing is like scheming or reasoning about the training process or something? Like, that would be great. Yeah.
All right. Yeah, I guess that's a whole lot of examples of low-hanging fruit that people might be able to pluck. I think all things considered, I'd really rather live in a more boring time in history. But I guess we don't exactly get to choose that. So we just have to go out and continue with all of this really useful work. And fingers crossed it'll be sufficient to get us over the line. Yeah. Is there anything else you want to say to the listeners before we wrap up? We've kind of run up against, I guess, the time limit of our booking at this place.
Yeah. yeah, like I said, everything to play for. Now is the time. If you're kind of being like, oh, I was going to go and skill up and do some things, and I'm working on capabilities until I'm like, now is
sometime in the future, maybe I'll do something useful. You're like, now is the time to do something useful.
Yeah, yes. Time to do something useful is running out. Also, if you're like sitting on money and not donating it, I think the sort of compounding returns of getting stuff started now such that it can be more mature at the time it's needed is just very high relative to other, things that are going, like learning or your money gaining interest or whatever. So I'm like, it just feels like we're in the sort of now is the time to act phase. And METR is hiring. Yeah. Come work at METR. We really need people.
Yeah, I imagine if things do go badly, there'll be a whole lot of people who are holding onto money and are still planning to, later do something useful with their career at some later point, who have missed the window, missed the boat. And I guess,
or it just like ends up being like way less useful than it could have been because you're like, oh, I guess, I started my job like 1 week before everything went down and I didn't know how to do anything, so it wasn't useful.
Yeah. Whatever. So inspiring words. People got to get on it.
Yep. Time to go.
My guest today has been Beth Barnes. Thanks so much for coming on the 80,000 Hours podcast, Beth.
Thank you.